Isipan ko'y nagtataka kung ba't hindi pumapasa. Nagbabasa naman ngunit di umubra. Pangarap kong mithi noon pa lamang una. Tanong ni ina, anak kaya pa ba? Isang araw naglalakad doon sa may Espanya. Nakita kong karatula at aking binasa, money back guaranteed when you fail the board exam. Tanong ng isip ko, totoo ba yan? Tinignan ko ang address at aking pinuntahan. Nakita ko ang engineer na may kagwapuhan. Sa pinto pa lang ramdam ko ang gaan. Mukhang ito na ang sagot sa aking kinabukasan. Tutukan, tutukan.
Sa powerhouse, tutukan.
Sa powerhouse ay tutukan.
Tutukan, tutukan.
Tutukan, tutukan.
Focus ang isipan.
Focus ang isipan.
Tutukan, tutukan.
Tutukan, tutukan.
Sa powerhouse, tutukan.
Sa powerhouse ay tutukan.
Tutukan, tutukan.
Tutukan, tutukan.
Spoon feeding ang gaan.
Clean restroom and air-conditioned classroom. LED TV whiteboard, comfortable around the room. Calculator technique, ang bilis kong mag-isip. May kapklas ang solusyon. If you're absent or you're sick, advanced calculator technique kung mag-solve anong lintik. Sa board ay di ka papasa kung basic ang yung click. Ngunit sa powerhouse, answer in your fingertips. Sa dami ng example, utak mo ay ang lupit.
Tutukan,
Tutukan, tutukan.
sa powerhouse, tutukan.
Sa powerhouse ay tutukan.
Tutukan, tutukan.
Tutukan, tutukan.
Focus ang isipan.
Focus ang isipan.
Tutukan, tutukan.
Tutukan, tutukan.
Sa powerhouse, tutukan.
Sa powerhouse ay tutukan.
Tutukan, tutukan.
Tutukan, tutukan.
Spoon feeding ang gaan.
Spoon feeding sa powerhouse ay in na in. Detalyado ang solution kung mag-solve anong galing sa paliwanag pa lang. Para kang grade 1, imposibleng di magets o di maunawaan. Handouts, lagi kang binibiyayaan kahit absent, kahit late o pumasok minsan-minsan di problema. Kung kailangan mong lumiban, makeup class or viewing ang iyong pupuntahan.
Tutukan, tutukan.
Tutukan, tutukan.
Sa powerhouse, tutukan.
Sa powerhouse ay tutukan.
Tutukan, tutukan.
Tutukan, tutukan.
Focus ang isipan.
Focus ang isipan.
Tutukan, tutukan.
Tutukan, tutukan.
Powerhouse, tutukan.
Sa powerhouse ay tutukan.
Tutukan, tutukan.
Tutukan, tutukan.
Spoon feeding ang gaan.
Ako'y naririto sa aking trabaho. Nag-review sa powerhouse. Tagumpay ay dala ko. Pagpapakumbaba ay natutunan ko. Kahit marami ang tawag sa akin ay amo. Ngayon ay alam mo na kung saan dapat pumunta. O pare ko'y huwag tatanga-tanga. Kung gustong makuha pangarap na lisensya. Kung gusto mo tutukan, pag powerhouse ka na.
Tutukan, tutukan.
Tutukan, tutukan.
Sa powerhouse, tutukan.
Sa powerhouse ay tutukan.
Tutukan, tutukan.
Tutukan, tutukan.
Focus ang isipan.
Focus ang isipan.
Tutukan, tutukan.
Tutukan, tutukan.
Sa powerhouse, tutukan.
Sa powerhouse ay tutukan.
Tutukan, tutukan.
Tutukan, tutukan.
Spoon feeding ang gaan. Tutukan, tutukan.
Tutukan, tutukan.
Sa powerhouse, tutukan.
Sa powerhouse ay tutukan.
Tutukan, tutukan.
Tutukan, tutukan.
Focus ang isipan.
Focus ang isipan.
Tutukan, tutukan.
Tutukan, tutukan.
Sa powerhouse, tutukan.
Sa powerhouse ay tutukan.
Tutukan, tutukan.
Tutukan, tutukan.
Spoon feeding ang gaan.
Break it down.
Na kay buti't ligaya, pagkakaisa sa bayang pinagpala, isang bintuklod ng pag-ibig na dakila.
Aral ni Kristo'y ibinabandila.
Kristiyano ako, Kristiyano tayo, pagmamahalan natin ang patunay nito. Ang ating daan ng katotohanan, bansang pangarap. Anong sarap na magkasama sa kapatiran. Tunay ang galinga, lumiliwanag na sa mundong natininlan. Ipinapahayag sa Diyos ang karangalan. Kristiyano ako, Kristiyano tayo. Ang mamahalan natin ang patunay ito. Ang mayang masikap sa mabubuting gawa. Diyos ang sandigan,
May pag-ibig, may pag-asa. Sana lang tayong gumagawa sa mabuhay o hawatan.
sa'yo'y
Nang natotohanan, bansang mahal at lahir ng mga hinirang. Ang bayang masikap sa mabubuting gawa.
Diyos ang sandigan, NCGI.
Sumasambang tapat sa buhay ng Diyos Ama. Sa isip, sa salita, mabubuting gawa. Kristiyano ako, Kristiyano tayo.
NCGI, West Church of God International.
Sa loob ng 57 taon ay walang humpay na nangangaral si Brother Eli Soriano sa iba't ibang platform. Unay face-to-face o yung mga pulong sa mga bahay. Sinundan sa radyo, telebisyon at internet. Ang paghihirap na ito ni Brother Eli ay hindi naging walang kabuluhan. Dahil may mga taong napukaw ang atensyon at nabago ang pananaw sa buhay, pumanaw man ang kanyang lupa. Certified plantita si Maria Lisa bago pa magkapandemya. Bukod sa nakakawala ng stress ang mga halaman, naging source of income niya rin ito sa pamamagitan ng online live selling dahil humina ang kita ng kanyang maliit na grocery store nang magkaroon ng mga lockdown.
Yan lang po kayo po. Dito po ako, lagi nagtatambay.
Pero ang higit na nakapagpapasaya kay Lisa ay ang panonood niya kay Brother Eli Soriano sa internet.
Simula po nagka-wifi ako, yung YouTube po talaga. Walang silbi yung YouTube kung wala po siya para sa akin. Tapos tuloy-tuloy na po yun. Akala ko noon, okay lang na nakikinig ako. Akala ko, salba na ako. Masaya na ako na gano'n.
Ngunit sa di inaasahang pagkakataon, umaga hanggang hapon, ay pahinga na ng Panginoon.
Tamang-tama, may bumili po. Ate, natingdang ka po. Sabi ko, ay hindi naman po, bakit po? Si Brother Eli ang pinapakinggan mo, di ba? Sabi ko, opo. Sabi niya, pinagpahinga na yan ah. Hindi ko po alam, binuhusan po ba ako ng malamig? Umainit.
Walang naisip na ibang paraan si Liza upang ilabas ang sakit ng kanyang kalooban kundi mag-live sa FB.
Sino po niya naman dating na napupunta doon ko sa Brazil, sasama ako.
Alam niyo po, masigit pa sa magulang kong hindi ako sa kanya. Kasi nung time na lamang kong nag-plus na diba pong nawala na talaga siya. Parang pakiramdam ko po, wala na bang pag-asa na maligtas ako. Bakit ngayon? Sabi ko, nalit na ba ako? Siguro po napanood niyo naman po yung live ko. Hindi ko po talaga hindi ko na nasabi ko pa po dun. Kaya nung nireview ko na, kahit mo walang asawa ko, hindi ako iiyak yun. Sabi ko talaga.
Nag-viral at umabot ito ng mahigit 1 milyong views at libo-libong shares noong nakarang taon.
Ano po ang iniwan ni Brother Eli sa puso mo po?
Ang iniwan niya talaga sa akin ng biro ng pag-asa, kuya. Dahil kung iwan ko lang, kuya, dahil sa ito na nga itong ano natin, kung hindi siguro sa mga narinig ko sa kanya, bumitaw na po siguro ako sa... Siyempre, sa edad ko po na to, grabe ang binatong problema sa amin, sa pamilya ko. Pero sabi nga niya po, yung pag-asa yan, number 1, hindi mamawala sa buhay natin. Yung po, pinangahawakan ko talaga na kahit anong dumating problema, pagsubok, pinangahawakan ko yung may pag-asa. Yun talaga, yun ang tinanim niya sa isip ko na pag-asa. At ang pagmamahal talaga, Brad.
Nag-trending din sa social media noong February 1, 2021 ang PUP student na si May Esmedia nang magtanong siya ng live kay Brother Eli higil sa isang mainit na issue ng mga kabataan sa universidad.
Nagulat talaga ako kasi the way how he talked to me, it's not like pakikipag-plastic na maraming filtering. Kasi yun yung hinahanap ko. Ayokong filteran mo ako ng words. Ayokong, kumbaga marami kang palabok. So, nung nakikinig ako kay kapatid na Ellie, although po siya, kumbaga, mas mabibigat nga po na salita. Yun nga po yung nasabi ng mga tao. I don't find it that heavy during that time. I find it na parang binasag niya yung lahat ng mga arguments at the same time, sinagot niya yung mga tanong ko mula pa noon hanggang ng panahon yun. Kaya yung makikita nila sa face ko noon, kasiyahan na pagkamalian pa nga po akong kaanib ako during that time because masaya ako na nagtatanong. But it is because kapag ikaw yung isang tao, kumbaga kung yung researcher ka and you are looking for information and nakita mo yung hinahanap mo na information na this is it! Yes! So masayang-masaya po ako noon.
Maluwag na tinanggap ni Rona May ang ipinangangaral ni Brother Eli. Ngunit, hindi na sila muling nagkausap.
Gusto ko lang po sana masabi sa kanya na kapatid na Eli, salamat sa Diyos na naging kasangkapan ka kasi nabago yung buhay ko, nabago yung pananaw ko, nahanap ko yung hinahanap ko sa tagal ng panahon. Salamat po sa Diyos. Although, syempre, sinabi ng mga tao na malalaki, mabibigat yung salita. Actually, para sa akin, yun yung kinagaan ng kalooban ko. Kung anong bigat ng salita, siyang kinagaan ng kalooban ko.
Pinagpahinga man ng may kapal si Brother Eli Soriano, ngunit ang diwa ng pagkalinga sa kapwa na kanyang naipunla ay nagpapatuloy sa tulong ng Diyos sa sama-samang paggawa ng bawat member ng Church of God International o MCGI. Ang social media savvy na si Lovely Soto, first time noon na mag-volunteer sa free store activity ng MCGI sa Las Piñas City. Hindi niya inakala na magba-viral ang post niya patungkol sa MCGI free store. Pati mainstream media ay tinampok ito dahil sa kakaibang konsepto ng pagbili sa tindahan nang walang binabayaran.
Hanggang sa yun nga po na naging kasangkapan po yung pagpo-post ko po, which is hobby ko lang. At natutuwa po ako doon kasi masaya rin naman po kung ginawa ko yun. Kaya maraming salamat po sa Diyos. Nagkaroon na rin po ng kabuluhan yung hobby ko lang. Ang social media, nag-aksaya lang ng oras ko. Pero ngayon, at least naging help na siya para malagana po ang mabuting gawain ng iglesia.
Sa mahigit 1 dekadang pangangaral ni Brother Eli sa Brazil, isa ang 26 anyos na si Carlos Miranda sa mga nabaling ang atensyon sa mga programa ni Brother Eli. 16 years old siya nang unang masilayan si Irmão Eli kung tawagin nila sa kanilang wika. Ang dating football fanatic, automatic na nag-switch ang panonood kay Brother Eli.
I remember that way back we had World Cup and football game. There was, everybody was into it. But listening to Brother Eli was something else, was something more interesting than ever. I remember we even prepared popcorn and soda to drink while we were watching, and we all prepare as if that's really, the big movie. The preaching of Brother Eli is amazing because he's not only talking of him. He's not talking what he thinks, but he's really preaching what's on the Bible. He's preaching what's in the Bible. For me, the faith that he passed, the faith that he shared to us, I have with me that no matter what happens, no matter what, we will have to continue until the end. We will have to follow the doctrines. That's the thing that I remember, that I kept with me, just like what Brother Eli did in his life. He gave his life working to serve the brethren. And we, with no excuses, we have to do as much as we can till our last breath of life.
Ilan lamang sila Lisa, Rona May, Lovely at Carlos sa mga nahipo ang puso ng salita ng Diyos. Patunay lamang na kahit wala na physically si Brother Eli, ay nananatili ang pananampalataya. Buhay na buhay ang pag-asa at maningas ang pag-ibig na kanyang ibinahagi at tinanggap ng marami.
Itong buhay sa lupa, puhunan natin ito kung magpapakabuti tayo para makasama tayo ng Diyos sa buhay na walang hanggan.
Patuloy na nagkakaloob ng libreng short training courses ang UNTV katulong ng Sophia Training and Consultancy. Ang mga kursong ito ay maaaring magamit ng ating mga kababayan upang makapag-apply ng trabaho, hindi lamang sa Pilipinas kundi maging sa labas ng bansa. Ito ang balita ni Grace Cassin.
Bilang bahagi ng public service ni Kuya Daniel na makapagbigay ng libreng edukasyon sa ating mga kababayan, nagbukas ng isang free training course ang Sophia Training and Consultancy, katulong ang UNTV para sa ating mga kababayan. Sa pamamagitan ng aksyon ni Kuya Free Short Training Courses Program, mayroon ng pagkakataon ng ating mga kababayan na sumailalim sa isang training kahit hindi sila nakapagtapos ng pag-aaral.
Actually, right after their graduation, we are referring them to we will refer them to our tie-up company. So namely, ito yung Beta Electric Corporation, LRT, MRT, at saka yung isang construction din, yung GTech Development Corporation. So actually hindi lang yung training nila namin sila i-guide hanggang sa paghahanap nila ng trabaho.
Sa ngayon ay Building Wiring Installation Course ang libreng inaalok ng UNTV at Sophia, at sa malapit na hinaharap ay magbubukas pa ng maraming kurso na maaaring pasukan ng libre ang ating mga kababayan.
Basta marunong bumasa at sumulat. So no required educational attainment, no kahit anong edad mo, of all ages siya. So pwede rin actually kahit babae kung may gustong mag-train.
Isa si Lolo Arsenio na sinamantala ang pagkakataon na matuto upang kahit papaano ay magkaroon ng pagkakakitaan.
Gusto ko kasing magkaroon ng income pa kahit na matanda na ako para maka-income nga ako. At rin ako sa mga bata pa, maengganyo sila na yung mga walang ginagawa. Makapag-aral din sila.
Bukod sa Sophia, nag-aalok din ng libreng training ang Pauline Joy Institute para sa ating mga kababayang nagnanais matuto ng healthcare, caregiving, housekeeping services, food and beverages services, at household services. Grace Cassin, UNTV News, Worldwide.
Ito naman, lubos ang naging kagalakan ng ating mga... Dahil nga sa ipinamahaging scholarship ng TESDA at sa pakikipagtulungan po yan ng UNTV. Narito po ang ating serbisyong kasangbahay.
Higit 200 mga kabataan mula sa Leyte ang pagkakalooban ng scholarship ng Technical Education and Skills Development Authority o TESDA sa pakikipagtulungan ng UNTV. Ang mga kabataang ito ay kabilang sa unang batch ng mga benepisyaryo ng pinakabagong programa ng ahensya, ang Skills Training and Enterprise Development o STED. Sa ilalim ng programang ito, 1,000 out-of-school youths mula sa tinatawag na Yolanda Corridor ang pipiliin at bibigyan ng scholarship grant. Bukod sa Leyte, pipili rin ng mga scholar mula sa Antique, Aklan, Capiz, Cebu, Iloilo at Palawan. Kabilang sa mga skill na maaaring pagpilian ng mga scholar ay ang housekeeping, food and beverage, electrical installation maintenance at shielded metal arc welding.
Magseryoso, katima, nga an bumulig hirahan panuyuan ini nga programa kay para man ini haira. Ki kami an ahensya ngan hinihiran redtos nabulig la kami pag-facilitate. So kinanglan nira timbangan seryoso ngan gamiton nira kung ano man matutdo.
Itinuturing naman na malaking tulong ang programang ito upang mabawasan ang kaso ng poverty incident sa rehiyon.
Isa siyang magandang paraan, isa siyang parang magiging key to success para magkaroon ng magandang kinabukasan para sa aming lahat.
Sa kasalukuyan, ang Eastern Visayas ay isa sa pinakamahihirap na rehiyon sa bansa.
Ayan, salamat ng marami. Napakaraming mga kababayan natin sa Tacloban ang napagkalooban nga ng scholarship program na hopefully makatulong ng malaki sa kanila sa kanilang pagtatrabaho at pagtatrabaho in the future. No? At naging kapartner nga natin dyan ang TESDA and of course ang UNTV. So congratulations sa lahat ng mga nabiyayaan at nag-graduate ng nag-scholar.
Margaret Asante finds strength in her dreams for her children, to be able to support them on her own. But most of all, she finds strength in God in everything she does for her children. But with her measly income from selling scarves, she needs to find means to earn more. Her wish is to have more products to sell in order to make ends meet and to support her children's studies. Members Church of God International found a way to help Margaret and granted her wish with God's mercy and guidance. Now she has more scarves to sell, plus MCGI free store items for the whole family.
It's a person na obi twa na makofa na mabeton enti menye bia na mede ama me mba no enti omo ba no mne me ebecheye no me ma na ndwun sese kra na me side ehunu ba eso mo bebre a we di se metime ton a metime di akofa bi e wo bi ho na te se me so eni ni na na se e kosoro anu with the radius iti meda asafwa eye MCGI.
At Benamao, thanks be to God for his wondrous works and his holy words. As it is written in Galatians chapter 6 verse 10, as we have therefore opportunity, let us do good unto all men, especially unto them who are of the household of faith. God's words teaches us to do good unto our fellow men as we have opportunity. That is why MCGI will uphold and cling to these words and couple it with action and faith, hope, and love, because MCGI cares.
Minsan po nagdidildig lang ng asin dahil may pinaglalaanan po akong gamot sa asawa ko po.
Hindi man nais ni Nanay Dina na maranasan ng kanilang 4 na anak ang pagdidildil ng asin. Wala silang ibang magawa. Dahil pangunahin ang para sa gamot ni Tatay Jason na sumasailalim sa dialysis.
Sa ngayon po, nagtitinda po kami ng mga gulay at prutas. Minsan, wala rin po kaming sapat na puhunan. Minsan, hindi po ako nakakapagtinda kasi sinasamahan ko po yung asawa ko po na magpapadialysis kasi hindi naman siya pwedeng walang kasama. Ang kinikita ko po sa isang araw ay 200 lang po. Hindi po sapat yung aking kinikita kasi 4 po yung aking anak. Tapos hindi pa po kami minsan nakakabili ng ulam.
Maging ang pamumulot ng basura upang ikalakal ay ginagawa ni Nanay Dina kapag nauubusan ng puhunan sa pagtitinda ng prutas at gulay. Hiling ng ilaw ng tahanan ay makapagtinda ng may tiyak na puhunan.
Ang kahilingan ko po na madagdagan yung aking puhunan sa gulay kasi hindi po sapat yung aking kinikita sa pang-araw-araw.
At upang maibsan ang pag-aalala ni Nanay Dina sa kung saan kukuha ng susunod na ititinda. Regalo ng Members Church of God International ay sari-saring prutas at gulay na maibebenta. Dinagdagan pa ng MCGI free store items para sa pamilya.
Unang-una po sa lahat, nagpapasalamat po ako sa Diyos at sa mga kapatid sa MCGI dahil sa ibinigay na puhunan sa amin at sa mga gulay at sa grocery po. Malaking tulong po ito sa aming pang-araw-araw po na pangkabuhayan.
Salamat sa Diyos sa kanyang pagtupad sa hiling ni Nanay Dina. Nawa ay makatulong ito sa gamutan ni Tatay Jason. Salamat sa Diyos sa kanyang kabutihan, kalooban ng Panginoon, ang paggawa ng may kabanalan na siya namang isinusulong ng MCGI gaya ng nasusulat sa mga banal na kasulatan na mga puspos ng bunga ng kabanalan na ito'y sa pamamagitan ni Hesukristo sa ikaluluwalhati at ikapupuri ng Diyos. Sa awa at tulong ng may kapal ay patuloy na ibabandila ng MCGI ang paggawa ng mabuti nang walang hinihintay na kapalit. Dahil MCGI cares.
Ngayon di nagpandemyan, natambay amin ti tao, marigata nakidinta, syempre awan ti brami kinilakay, awan mo ti pangalaan mi ti pagbiag min, ururayan milatan dagiti kaasi ti gobyerno.
Isa lamang ang pamilya ni Nanay Sonia sa maraming mag-anak na nahihirapan ngayong may pandemya. Namamasukan ang 43 taong gulang na ina sa isang karinderya kahit maliit lamang ang sweldo niya rito. Ang asawa naman niya ay walang hanap buhay sa ngayon. Naghihigpit ng sinturon araw-araw para magkasya ang kanilang panggastos, lalo na 3 ang kanilang mga anak.
Binbin na teklat na dagi duwa gasutin. Dagi latan importante talaga nga gatanga kon. Kaya dagi masidamin. Basta wag uray hana makagaga dagi kuan basta importante magatang ko jay talaga nga masapol ti panagbiag mi.
Nais ni Nanay Sonia na magkaroon ng sariling negosyo kahit maliit.
Wish ko kahit dagi kahilingak nga dagi pang negosyo ko mati pang barbecue, dagi pang merienda, tapos kumati pansit kadakwa, tapos dagi isaw. Ken dakkel ti may tulong dati pang inaldaw-aldaw ko ajay ta adanto ti pangalala akon ti inaldaw-aldaw min.
Ang naaawa sa dukha ay nagpapautang sa Panginoon at ang kanyang mabuting gawa ay babayaran sa kanya uli. Ito ang bilin ng mga banal na kasulatan. Kaya naman ang Members Church of God International sa gawang mabuti ay hindi nag-atubili. Ang sorpresa kay Nanay Sonia ay katuparan ng kanyang hiling sa awa at tulong ng Panginoon. Mga kagamitan at sangkap sa pagtitinda ng grilled meat at merienda.
Maraming salamat po sa MCGI Cares sa pinagkaloob po sa amin. Malaking tulong po sa amin ito, sa pamilya ko.
Salamat sa Diyos sa isa na namang pagkakataong makagawa ng mabuti sa kapwa. Pagkilos ng Diyos ang nakapangyayari sa bawat kawang gawa ng MCGI. Pagtulong sa kapwa na walang hinihintay na kapalit na magpapatuloy ayon sa kalooban ng Diyos ng pag-ibig. Dahil MCGI cares. Isa ang Fundasyon Kristiyana Ama at Prójimo sa mga ampunan sa Dominican Republic na kumakalinga sa mga batang inabandona at laman ng mga lansangan. Sa pagsisikap ni Ginang Evelyn Amarlis Pereira na itatag ito. Ang kwento niya, bunga ito ng isang mapait na nakaraan. Iniwan siya ng kanyang ina sa ospital pagkapanganak sa kanya at sa kanyang paglaki, nagpalipat-lipat ng ampunan at naging laman ng kalye.
Y si veo un niño en la calle, pido permiso y me lo traigo, porque como yo fui una niña de calle, sé lo que sufre un niño y yo no tengo niños. Y los niños pueden estar conmigo hasta que lo deseen, pero le buscamos la forma de que esos niños y niñas puedan tener un mejor futuro con nosotros.
Nakatatanggap ng tulong ang ampunan mula sa kanilang pamahalaan at ilang grupo. Subalit hindi pa rin sumasapat para sa lahat ng kanilang inaarugang bata. Nagpaalam na rin ang iba nilang empleyado dahil wala na silang pansweldo, kaya't iba't ibang paraan ang ginagawa nila upang may dagdag pondo. Para kay Ginang Evelyn, mahalaga na mabigyan ng edukasyon ang mga bata, subalit kulang naman sila sa mga kagamitan.
Porque realmente lo que necesitamos, y sobre todo en la educación. Oye, hay muchas cosas que ellos quieren estudiar, pero yo no tengo los recursos para... Por ejemplo, yo tengo poca tablet porque no tengo casi dinero para comprarla y tengo que agarrar 2 o 3 tablets para que ellos puedan hacer las tareas. Entonces tengo que esperar que uno haga la tarea para que se la preste al otro y asesivamente.
At dahil sa pandemya, lalong nahirapan makalikom ng pondo ang ampunan, kaya't kailangan nila ng tulong.
Pero ahora mismo necesitamos ayuda porque realmente la pandemia que ha sido una peste en el mundo entero. Nosotros por este medio pedimos a ustedes que si pueden ayudarnos a nosotros, puede ser con comida.
Upang magkaroon ng dagdag na pagkain ang ampunan ng mga bata, ay granted ng Members Church of God International ang kanilang hiling sa pamamagitan ng MCGI free store items. At maging ang tablet na kanilang request, granted na rin sa awa at tulong ng Diyos.
La honra y la gloria sea de Dios. Le agradecemos al ministerio por los alimentos para nuestros niños y niñas y adolescentes en nuestro hogar. Y esto que me dejaron con la boca abierta, pues realmente lo necesitábamos. Muchas gracias a Dios y de verdad me han dejado sorprendido y cómo Dios contesta nuestras oraciones.
Ang lagi nating pag-asa ay ang awa at magagawa ng Diyos na makapangyarihan. Lagi nating ilagak ang lahat sa Kanya, kahit na ang mga munting hiling, gaya ng dalangin ni Ginang Evelyn. Salamat sa pagkakataong bigay ng Diyos na hindi palalampasin ng MCGI upang makagawa ng mabuti nang walang hinihintay na kapalit sa silangan man o kanlurang mga bansa. Dahil MCGI cares.
Hello, magandang hapon po sa inyong lahat mga kawerpa. Magandang hapon po sa ating mga participant. Hello. Magandang hapon. Kaway-kaway naman konti dyan. Hello po, hello. Magandang hapon sa inyong lahat mga kawerpa. So welcome po sa ating pong ginaganap po na mentoring program, no? Today is March 1, 2022, no? So magpasalamat po tayo sa UN Television, your public service channel, no? Sila po ang ating major sponsor for this event, no? So this would not be possible, no, kung wala po ang ating mga ka-partners, ang ating major sponsors at yung ating mga minor sponsors, no? So later partner, no, makikilala nilang dalawa pa sa ating minor sponsor, ano? Okay, so ang ating mga major sponsor for this event is UNTV, your public service channel, and the IIEE, Institute of Integrated Electrical Engineers of the Philippines. Okay? So, sige partner, hindi na natin pagtatagalin, no? Tayo'y magpasimula na sa ating mentoring program.
Recording in progress.
Okay, so let's go with the number 1 question of the day. So, let's have Mr. Jubert Gaboa. Is he connected, partner? Hello, Kawerpang Jubert. Magandang hapon sa iyo. Rinig ba ako ng maayos? So, tama ba pinadala mo tong question na to, no? So, we need your confirmation, no? So, napaka-importante po niyan, mga Kawerpa, no? So, para hindi naman masabi na itong ating ginagawa ay self-serving, na tayo lang lagi yung gumagawa ng questions, no? Ito pinapadala ng ating mga kawerpa, no? So sa kanilang mga request for their board exam preparations, no? Not only board exam preparation, even yung ating mga college student, kung meron silang mga examinations in preparation, pwede silang magpadala ng mga questions, no, as their review preparations sa mga examinations po nila sa school, not only for board exam, no? So we are here to help you guys, no? At magandang hapon po sa ating mga kawerpa na nanonood ng ating Facebook Live, partner. Tama, no? Connected tayo sa Facebook Live. Magandang hapon po sa inyong lahat, no? At we welcome you sa ating pong MPHT Review Center REE and RME Mentoring, no? So mas maganda kung mag-join tayo dito sa ating Zoom class na ginagawa, no, para mas focus tayo, no, at kayo po ang bibigyan namin ng priority na makapagtanong, no, yung mga nasa Zoom class, no. So ipadala nyo lang po, no, yung inyong mga questions yung nasa Zoom class natin, no. So kayo po ang welcome na magpadala, whether you are our student or not, no, whether you are our enrollee sa aming review center o hindi, welcome po kayo, basta't kayo po ay nandiyan dyan sa ating Zoom class, partner, no. So, kami naman po ay nag-attendance din dito, no? So, ang priority po na sasagutin natin ng mga questions yung nagpadala po, no? Sa atin na mga participants sa ating Zoom class. Ayan. So, that's the difference, ano? So, okay, mga kawerpa. So, okay, Jubert. So, ito po ang iyong katanungan na pinadala po sa amin. So, sasagutin natin. A motor supplying 70 Newton meter to a load. If the shaft of the motor rotates at 1,500 RPM, determine the power developed in motor. So, ano daw yung power na na-develop dun sa motor natin? Okay? So, let us go here sa ating board. Okay, pagka sinabi nating power develop, no? Power develop. No? So, it refers to a motor, whether it is DC motor or AC motor. Okay? So, it refers to an electric motor. Okay? Power developed by the electric motor. Okay? So, that is the power being developed at the rotor shaft, no? The rotor or the shaft of the motor, no? So, the power developed is, we have here, let's say we have a motor, no? And then this drive a certain load. Okay? So, as it drives this load, there is a power output here. The power output, basically, that is the horsepower of the motor. Basically, it is the power developed. Okay? So let's say we designate this as P sub D. Okay? Power output, horsepower, or pag sinabi nating horsepower of the motor, automatic po yun mga kawerpa. Ito po yung output power ng motor. Kasi may tinatawag na input power ng motor. Ano ba yung input power? So the input power, ito po yun. Yun yung power na pinapasok ng ating source, no? Going to our motor. Okay? Going to our motor. Okay, in generalize natin, in DC motor, no, let's say, in DC motor, if we mean power input, basically the power input is the input voltage multiplied by the input current, which is basically equal to the voltage of the motor. Let's say, sabihin doon sa problem, a 230 volts shunt motor. Automatic yan po yung voltahe po, no, na isusupply mo doon sa motor mo. That is your voltage V. What do I mean? Let's say we have a shunt motor here, no? So kung meron tayong shunt motor dito, let's say ito yung shunt motor natin. Okay, so ito po yung shunt motor natin. Then we have our voltage V. So, let's say if this is a 230 volts motor, meaning that is your input voltage to your motor. Let's say this is your motor, this is your input voltage. That is your supply voltage. If we mean input voltage, that is your supply voltage. No? So, we have here our line current, no? Then this is our armature current, and this is our field current. Okay? So, inside a DC motor, so we have here a generated or the back EMF, no? The back EMF is also the generated voltage of the motor. Once umikot yung motor mo, nagge-generate ng voltahe yan. Once umikot yan, no? So, and then this resistor, let us represent this as R sub A. That is the armature resistance. Okay? So, the power input in DC motor, okay, it is the input voltage, which is your line voltage. No? The other book, they would designate this as V sub L. Let's say V sub L. And then multiplied by IL. That is the line current. That will be your input current, your line current here. No? Yan na po yung input current natin. What about for the case of an AC motor? In AC motor, sa AC motor po, ang power input natin, dalawa yan. Depende kung anong motor mo. Kung single phase ang motor mo, our power input, it would be the voltage line, simply the voltage, the current, multiplied by the power factor. Power factor would mean our cosine theta. Cosine theta or power factor. Okay, so if you have a three-phase motor, okay, or three-phase motor, the input power is always square root of 3 line voltage, line current times the power factor. So the difference is just meron lang tayong square root of 3, no? So ganun po yan. So meron tayong square root of 3. Okay. So for this case, so ang power developed, no, o ang horsepower ng motor natin, we have basically two formulas. So we have the horsepower is equal to 2 pi NP over 33,000. No? So that is the first formula. The second formula is horsepower, that is 2 pi NT over 44,760. Always remember, kung ito po ay 33,000, ito pong torque natin, foot-pound or pound-foot. Foot-pound, pound-foot would mean the same. Okay. 44,760, if our torque is in Newton meter. Okay? So that's the difference between the two. Okay? So now we can now easily compute, no? So determine the power developed, okay, which is again, that is also our horsepower. Okay? So we'll be using, so we have basically two formula for horsepower, okay? since our given here is in Newton meter, so meaning in metric system, we'll be using this formula. So we have here 2 pi n. N is the speed, okay? So let us just substitute the speed, which is 1,500. And then the torque is in 70 Newton meter, okay? There you are. The RPM, of course, is revolution per minute. RPM, this is also RPM, okay? So we have here our 44,760. So let us calculate now the horsepower, okay? So kunin natin yung horsepower po na yan. Ilan po ba yung horsepower natin? Our horsepower okay, so this is our horsepower, no? So we have 2 times pi, okay, times 1,500 times 70, okay, then divided by 44,760 equals, okay. So our horsepower will be 14.74 horsepower. So we just have to multiply it by 746, sorry, 746 watts, no? So this is per horsepower. Of course, we can cancel out our horsepower, okay? Horsepower will cancel out. Okay, our value, okay? So the power developed, no? The power developed will be equal to, so 14.74 times 746, that is equal to okay, so 10,996, 996.04 watts. Okay, so this is our answer. Okay, so 10,996, and that will be letter A. Okay, Jubert, so that is my answer to your question. It is 10,900, no, 996. Let us double check. 14.74 times 746. I think there's just a typo error. Okay, so it should be 10,996, not 966. Well, anyway, so if that's the case, of course, still you will be considering the nearest answer, okay, which is letter A. Okay, Jubert, so that will be my answer to your question. Okay, thank you. Salamat.
Recording stopped. Recording in progress.
Okay, mga kawerpa, we have a question here, no? So, being sent by our kawerpa, no? Mr. Jubert Gaboa. Okay, Jubert, so he's connected. Okay, so the motor has a nameplate rating. Nameplate rating is 15 horsepower, 1,160 RPM. Solve the rated torque. Solve the rated torque. Okay, so let's take a look at the unit of the torque that is in pound-foot. So meaning, we'll be using the formula, okay, the formula here. Okay, I'll give you the formula. So that is horsepower. Okay, that is an English system formula. Horsepower is equal to 2 pi the speed and then the torque in foot-pound all over 33,000. So that will be our formula. Okay, that will be our formula. So we have here 15 horsepower. Let us substitute here. So we have 15 horsepower. That is 2 pi. 2 pi. Then what is our speed? So 1160. 1160. Okay. Then we have a torque. Then we have 33,000. Okay, let us just shift solve this one in our calculator. So what will be our torque here? Or can be easily be manipulated, no? Okay. We can have it 15 times 33,000, then divided by 2, divided by the pi, then divided by 1160. That would be equal to 67.92. The nearest is letter B, no? Okay, so this will be our answer. 67.92 in foot-pound, no? Or pound-foot. Pound-foot. Okay? Pound-foot. So that will be our answer. No? Okay? Okay, so that will be our answer, no? So, anong letter, partner? So, letter B is our answer. Okay, I will show you another solution or another formula for this. So we can have this one. We can have this. Okay, so we can have the torque. Okay, that's equal to 7.04. Okay, this is applicable both AC or DC motor. Okay, so torque is equal to 7.04. Okay. Okay, so the power developed, okay, power developed over the speed of the motor, speed. Okay, in AC motor, this is what we call the speed of the rotor, this one, that one. Okay, and the answer for this is in English system, in pound-foot. That will be in pound-foot. Okay. Let us try this one. So, what will be the torque? Will it give the same answer? Let's double check. So, just come into my mind. I just remember this formula. No? That's why stop a bit. No? So, we have here the power developed. The power developed basically is equal to the horsepower. It's basically equal to the horsepower. So, what is your horsepower? Given already, which is 15 horsepower. So we just have to multiply this one by 15 horsepower, and then let us multiply it by 746. So this is 746 watts per horsepower. Okay? And then that will be divided by the speed of the rotor. Basically, that is the speed of the motor. The speed of the rotor is the speed of the motor. Okay? So, we have here the speed. We have here 1,160. So, our answer, it would be equal to, so ano ang sagot natin dyan? So, let us take a look here. 7.04 times 15 times 746. And then, divided by 1160. That will be equal to 67.91. That will be our answer. 67.91. And that will be pound-foot. That will be our answer. Okay? Just the same, right? Just the same here. So, kahit ano gamitin mo dyan. No? Either you use this formula, this is the horsepower, we use this torque. So, kahit ano gamitin mo dyan, parehas naman yan. No? Parehas naman. And this is a little technique, no? This is a little technique. Baka makatulong po sa inyo sa board exam. So, tawag lang nung ano ko dito, nung aking dating kong professor, tawag niya dito sa formula na to. Ito tawag niya. Para lang maalala nyo. Okay, so number 2 starts with the letter T. T. Now, T is 2. 2. Starts with the letter T. He used the word teenage. Teenage. Okay? And then, when he saw this symbol, it's just like the, the house of a turtle. No? These are mutants, right? These are mutants. Teenage mutant. Mutant Ninja Turtles. You see? So, this is Teenage Mutant Ninja Turtles. You see? So, madali mo maaalala yung formula. Kasi naalala mo yung teenage starts with the letter T. This is teenage. This is like the house of a turtle. No? Para siyang bahay ng pagong. Teenage Mutant Ninja and is Ninja Turtles. Okay? Nakakuha ba yun? Makaka-aware pa? Nakasunod ba doon? Okay. Ang magiging basihan mo lang dito is, the basis is the constant here. Okay? Always remember, if that is English system, that is 33,000. If this is metric system, Newton meter ang torque natin, and that will be 44,760. Okay? So, okay, that will be nearest to letter B. That is our answer. Okay, aware pang Jubert? So, naintindihan ba yung ating kasagutan? Okay, sige. So, salamat sa iyo. Thank you. Salamat po.
Recording stopped. Recording in progress.
Okay, so we have a question from Jonathan Cancino. Is he connected, partner? Pwede tayo makipag split screen sa kanya. Is he connected, Mr. Cancino? I hope he is connected. Is not connected, partner? Hindi siya konektado. Anyway, sige po. Konektado man po siya o hindi, okay lang. At ito'y makikita niya rin naman ang ating pagsagot. Dahil lahat po ito ay ina-upload natin sa ating YouTube channel. No? Pwede niyong balik-balikan po ang video coverage namin na ito. Okay? So let us answer this problem. This is about the DC motor. Okay. A 15 horsepower, 220 volts shunt motor has an efficiency of 87%. At full load, the resistance of the field is 440 ohms. What is the full load armature current? So, ano daw yung full load armature current? Okay? So, always remember, ang ating mga sinasagutan po dito, these are past board questions. No? Mga past board exam problem na po itong mga lumabas na ito. Kaya pwedeng maulit, no? At least may guide na po kayo. At totoo naman, may mga board exam questions talaga na paulit-ulit po lumalabas. Okay? Sige, so, meron tayong shunt motor dito. Sketch lang po natin yung shunt motor natin. The shunt motor, okay, in the armature, there is a back EMF and the armature resistance, RA. Okay? And then, we have here the, what we call the shunt field. There. So, we have the voltage here. Okay? Basically, this is our armature. Okay? Armature natin to, armature. There. That is our armature. So, we have here our line current. Okay? This is our line voltage, V sub L. Line voltage. Okay? So, or the supply voltage, no? So, we have here our armature current. Then, this is our field current. No? Yan po ang ating field current. Of course, that is flowing to our field resistance. No? Field resistance RF. There. Okay, by Kirchhoff current law at this node. What is the Kirchhoff current law at this node? There. Okay. The input current is equal to the output current at this node. No? Yung kuryenteng pumasok, equal siya doon sa lalabas na kuryente. So what will be our input current here? That will be our IL. Take a look here. I'll just put it here. Take a look here. So our IL, that will be, okay, I'll just put it here. Okay, so IL, that will be equal to IA plus IF. That is our shunt field current here. So I just call this as LAF. L-A-L-A-F. LAF. Okay, see? LAF. Okay, our given here is the power output. So let us put here the power output of our motor. Again, if we have our armature, then it drives a certain load here, there. So our power output is 15 horsepower. Then our shunt motor, so we have here 220 volts. We have an efficiency, okay? Efficiency is how much? 87%. And the resistance of the field is 440 ohms. What is the full load armature current? So this is the question. That is the full load armature current. Okay, so remember, we are given here the efficiency. So our efficiency, it will be equal to, of course, power output over power input times 100%. Basically, our power output here is our horsepower. You see, our horsepower multiplied by 746, so that we can have in watts here, no? The power output. The power input is the input voltage. Isn't it that the power is equal to VI, right? Basic formula of direct current circuits. So we have here our line voltage multiplied by the line current, which is our IL. So that is times 100%. See? There. Now, let's take a look here. So, what is our IL? Again, that is IA plus IF. Okay. So, we can solve for IF here. So, what is our IF? By Ohm's law, so we have here our field voltage over our RF. So, that will be equal to what now? What is our field voltage? Isn't it? This is just a shunt motor. A shunt motor. So, whatever the voltage here is also the voltage here, is also the voltage here. Because they have just connected in parallel. Equal voltages, right? So, equal voltages lang yon. So, we have here 220 volts. Okay? Yun din ang voltahe natin dito. Then we have our RF, which is 440. Okay? And 0.5, right? Okay, so we have 0.5. There you are. Okay, so we can now solve this one. Our efficiency is 87%. I will just make it in a decimal form. Okay, 0.87. 0.87. And then that will be equal to, what is our horsepower here? Our horsepower is 15 horsepower. Okay. This is multiplied by 746 watts per horsepower. Of course, this will cancel out, right? That will cancel out. Okay. That is our power output. Okay. What about the power input? Our VL here, our VL is 220, and then multiplied by IL. What is again our IL, which is IA, isn't it? IA, and then plus IF, we already have the value, that is 0.5 ampere, 0.5. Okay, shift solve this one, or just simply manipulate this one as looking at our equation. We can manipulate easily this one. So, let us have this equation. No? Let us cross multiply here, and then the 0.87, let us put here. No? Let us just replace the position of this equation to 0.87, right? So, ganun lang. Okay? Papalitin mo lang ng pwesto. So, we have here 15 times 746 divided by 220. Again, then divided by 0.87 equals. Okay. So, and then we just have to transpose the 0.5. Okay, so minus 0.5. There you are. I have here 57.96. This is my answer. 57.96 amperes. And that will be letter B. Okay? Let's take a look here. Okay, Jonathan. Hindi nga pala siya connected, no? Okay. So, that will be my answer to Mr. Jonathan Cancino. No? So, actually, nagtanong na rin siya last time sa atin. Ano? So, last time present siya. No? Sabi niya atin siya. So, anyway, so, ayan po ang aking kasagutan. Okay. So, maganda ito kung mga ginagawa po natin kasi karamihan po dito mga past board questions. Ano po? Okay? Mga naibigay na po sa board exam at po pwedeng maulit po sa inyo pong board exam pong muli, no? Okay? May mga board exam questions po paulit-ulit lumalabas, no? May mga ganun po talaga. Okay? So, that will be, thank you Mr. Jonathan for that question. Thank
Recording stopped. Recording in progress.
Okay. The next question is from Mr. Brent Carl de la Piedra. Is he connected, partner? Brent? Okay, so hindi connected si Mr. de la Piedra. No? Wala ba? De la Piedra is not connected. Hindi siya connected. Anyway, sige. So, may tanong dito si Mr. de la Piedra. So, here is his question. Tanong ko lang, ano po yung tinatawag na wall counter spaces and countertops, no? So, kasi ito, ginagamit to ng mga terms, no? Sa mga board exam questions, no? So, ano daw yung ibig sabihin ng wall counter spaces, tapos countertop, no? Try muna natin, ano ba yung wall counter spaces, no? So, yung wall counter spaces, no? Sige, sabay na natin sagutin, pati yung countertops. Ito po, para mas maunawaan natin, meron po tayong picture dito. Pag sinabi natin wall counter spaces, nasa wall siya, no? Nasa wall. No? So, and countertops, no? Yung countertops, okay, halimbawa, no? Kita natin. Ang ating countertops, halimbawa, yung ating makikita naman natin diyan yung ating picture, no? So, yung countertops natin, let's say may lababo dito, no? Siyempre, tiles to, di ba? Tiles. These are tiles, no? You have your kitchen sink here. Okay, you have your electric stove here, let's say, or gas stove here. In here, you will see here a GFCI, no? So, because this is a wet location here, so you need a ground fault circuit interrupter here. Okay. The receptacle outlet that serves counter top surfaces requires GFCI protection for personnel. Okay? So, kasi dito, wet location. Pwedeng mabasa. No? So, these are countertops. Then you have your kitchen here. No? Let's say you have a microwave oven here. You need a GFCI protected outlet here or receptacle. This is the countertop. That is the countertop. No? That is the same level with our kitchen sink. Let's say these are the countertop. Okay. Let's say this is the top of our gas stove or electric stove here. So these are the countertops. That one also. Okay. Okay, so yan po, yung mga countertops natin. Yan, you see, countertop. Yan po yung countertop natin. Okay. See? Countertop. Then, Wall spaces meaning these are spaces on the wall, no? Being utilized, no? Let's say you are going to put a cabinet here, no? So meron kang cabinet dito. These are the wall spaces. Wall spaces. See? Okay? So you have your cabinet here. Sometimes, no? In the wall spaces, you put there your panel board, right? Your panel board. Okay, so in the wall spaces here. Okay, and of course, you have your cabinet there, no, wall-mounted cabinets. Okay, so that is what we call the wall spaces, no? The spaces being occupied by your wall-mounted cabinets, no? Okay, just like this one, no? Okay. So, ayan po yan, no? Yung countertop, ito naman yung countertop. No? Let's say, may gripo tayo dito, no? So, may countertop dyan. Okay, so that will be my answer. Thank you.
Recording stopped. Recording in progress.
Okay, so another question from Mr. Brincar de la Piedra. Okay, is he now connected, partner? Please double check. Mr. de la Piedra. Okay, so anyway, so ito pong tanong na to, this is a past board exam problem. Past board problem. Okay, circuit breakers shall be marked with a voltage rating not less than the nominal system voltage that is indicative of their capability to interrupt blank. Okay, to interrupt blank. Okay, so you have your Roman numeral 1, 2, and 3. Number 1 is fault current between phases. What do you mean first by the fault current between phases? Okay, well actually, this, as I read this, no, number 2, fault current from phase to ground, okay, fault current between neutral and ground. This basically refers to 3-phase 5-wire. I'll show you the connection. 3-phase 5-wire. Actually, it is being used today, no? So, ginagamit natin ngayon to. So, itong 3-phase 5-wire na to. Let's say this is phase A, phase B, and phase C. Then you have your neutral here. That is your neutral. Okay? That is your neutral, and then there is another wire here. There is another wire, no, from the neutral point itself. And then another wire extending here, and that will be our ground. Basically, the neutral conductor, no, usually color white, and the ground color gray. Okay, so the neutral, we need the neutral for us to be able to supply the nominal voltage, which is 230 volts. Let's say 230 volts. The 230 volts, that is our line to ground voltage. Basically, that is line to ground or the phase voltage. Phase voltage. We read this as phase voltage. B phase voltage. Okay? That is our line to neutral voltage. B line to neutral voltage. No? Line to neutral voltage. Now, let's say you have your from B to C. This is our line voltage, which is the voltage from B to C. Okay? The voltage from B to C is basically 400 volts. The line to ground is 230. It came from 400 divided by square root of 3. Okay? So 400 volts divided by square root of 3. Because as we recall, no, in Y connection for 3-phase, no, for Y system, for Y connection, no, our phase voltage or our line to ground voltage or phase voltage, in motor it refers as coil voltage. Coil voltage. But for this case, this is a line to ground voltage. The line to ground voltage is simply equal to line voltage over square root of 3. See? That's why if we have 400 divided by square root of 3, that will give us 230 volts. Now, we mean fault current between phases. What do you mean by fault current between phases? It can either be AB, okay, there is a short circuit in AB here, short circuit in AB, or in BC, or in CA. That is between phases. If we mean phases, we are referring to the line. We can also say that it is fault current between lines. Okay? Between lines. Okay? Now, what do we mean by Roman numeral number 2? Fault current between from phase to ground. The phase to ground is the line to ground. Because the word phase is synonymous to the line. So, there is a short circuit somewhere here. Like this one. That is a phase to ground. Face to face, it's not face to face plus, no? So, face to face meaning line to line fault. Nagdikit ng dalawang linya mo. Yan. Face to ground, no? Is line to ground fault. Okay? This one. Because this is connected. There is a ground here. Right? There is a ground here. Okay? Fault current between neutral and ground. Okay. I will put a short-circuiting conductor between neutral and ground here. Question. Are they shorted? Okay. Electrically, are they shorted? Yes or no? Take a look here. This is your neutral. This is your ground. Are they shorted? The answer is no. They are not shorted. Why? Because they are already shorted. They are already connected here. You see? Diba? Sabi nga ng kuya ko kaya ka sinisiraan kasi hindi ka naman sira Buo ka di ba? Ano ba kinalaman? Hindi mo na pwedeng sabihin na wala ito, sira na sa akin to. Hindi mo na kailangan sabihin yun dahil sira na talaga yun. Di ba? So, ito, the neutral and ground, no? Actually, they are together here in the neutral point. They are connected to each other. Pagpasok, this is found on the transformer. Pagpasok sa loob ng building yan, magkahiwalay na yan. In fact, in the panel board, if you have your panel board, no, in your commercial or industrial building, there is a separate bar or point here. Let's say somewhere here, no, somewhere down the road here. So this is the neutral bar. This is the ground terminal, neutral terminal. They are separated here. But if you are going to trace that, going to the transformer, they are connected to each other. Basically, you still have to put conductor here. They are not considered to be short circuit. They are not short circuit. No problem. No, kahit magdikit yung dalawa na yan, walang effect yan. No? Walang epekto yan. Kasi pag tin-race mo yan, papuntang transformer yan, talaga naman magkadikit yan You see? If there is a fault here, since this is a ground, that will just drain the excess current due to short circuit. No? But basically, no, they are not shorted. The neutral and the ground, they are not shorted. So that is why the Roman numeral number 3, we cannot consider this, especially if we are talking of board examination. There's no such thing as the fault current between neutral and ground. No? Hindi mo pwedeng sabihin yun. May fault current, nagdikit yung neutral tsaka sa ground. Kasi talaga naman magkadikit na sila. Hindi mo pwedeng sabihin yung maganda ay maganda. Hindi na, maganda na talaga yun. Di ba? So, ganun lang. No? So, my answer is Roman numeral 1 and 2 only. No? Letter B is the answer. See? That is my answer, Mr. De La Pedra, to your question. Thank you. Salamat.
Recording stopped. Recording in progress.
Another question, no? Dami pa naman pinadala ni Mr. De La Piedra na tanong, ano? Wala siya, partner, no? So may we request, pag nagpadala kayo mga kawerpa, no, yung mga nasa Zoom class natin, pag nagpadala po kayo ng mga questions, sana po ay nandiyan dyan kayo, mas maganda po yun. No? So mas maganda. We prefer, okay? Not required, but we prefer. No? So, the continuity of an electrical circuit can be determined in the field by the means of, okay? What do you mean by the field here? No? Okay, well, basically, we mean the field in the, let's say, in the job site. Okay? So, basically, you have to bring your meter, your ammeter. Nowadays, we call this as the clamp ammeter, right? You will check if there's a current flowing here. No? So, Wheatstone bridge is a very theoretical bridge or system. No? So, it's not this one, it's not this one. The bell and battery set is not this one. Wattmeter, so very complicated. Also, you have to check your DI cosine theta. So no need for this. You just have to know the continuity. If there is a continuity, meaning if there is a current flowing, if we mean a continuity, no? If we mean a continuity, if there is a current flowing, okay? So my answer here for this question is the ammeter. Ammeter. That is my answer. Okay? So, thank you for this question.
Recording stopped. Recording in progress.
Okay, so I think Mr. J. Reblando is connected, no? Nakita ko siya. Okay? Connected siya kanina, nakita ko. Ayun, is connected. Okay, hello Jay, magandang hapon sa iyo. No, tama ba pinadala mo ang tanong na to? Thumbs up naman dyan. Thumbs up na lang. Ayun, okay. So, this is your question, ano? Sige, so, let us answer his question, mga kawerpa, no? So, the service feeder capacity necessary to provide for 6 5 kilowatt household electric clothes dryer. So there are 6 5 kilowatts clothes dryer. Okay. Board exam wise, this is what you are going to do. Since there is no table being provided, no? Okay, in the licensure exam, so sometimes you need some rule of thumb, no? Meaning what is generally being used, no? The rule of thumb, no? Okay, so that you can easily compute. The question is the service feeder capacity. What do you mean by service feeder capacity? So you have your 6 household, of course. Of course, here, let's say you have your circuit breaker, no? And then there are clothes dryers. So we have 1, 2, 3. Okay, 4, 5, then 6. Okay, 6. What do you mean by the service feeder capacity? Service feeder capacity. Remember, if we are talking of the capacity of the circuit, capacity of the branch circuit, capacity of the service feeder, no, we are referring, no. We are referring here to the size of the breaker, not the opacity of the wire. No, we are referring. Remember that the size of the circuit, it refers to the size of the circuit breaker, not the wire, not the opacity of the wire. So, we have here, this will be your feeder breaker, no? Your circuit breaker, or shall we say your feeder circuit breaker. Okay, if we mean capacity, no? Capacity. This is my experience reading the Philippine Electrical Code. If we mean the capacity, we mean, no, maximum allowed by the code. That is the maximum allowed. For example, what is the capacity? No, branch circuit capacity is allowed for this. Any load. What is being allowed? It is being written in the electrical plan. Do not exceed 80% of the size of the branch circuit. The size of the branch circuit is the size of the circuit breaker. So, this is 80%. Okay? For example, we have a circuit breaker 20 ampere. So we have 0.8. So we have here 16 amps. That will be your capacity. That is the maximum allowed by the PEC. Although, of course, okay, isa 20 amperes to, kaya ng hanggang 20 yan. Yes, of course. Yes, of course. Basta huwag lang pirata yung breaker. Ha? Isa kasi yung breaker, pirata. Minsan 10 ampere, nagtitrip. Ay gano'n. At a normal, at a good brand, no? A good condition, if we mean 20 ampere, it can really carry 20 ampere. But, there is a certain, shall we say, safety factor from the code. Do not exceed 80% so that you still have an allowance there, especially during overload condition. That is why the code introduced us a certain safety factor, which is 80%. Do not exceed 80%. That is why, if we have 6, okay, let us get now the, shall we say, the service feeder capacity. Let us call this a service feeder capacity. So, we have here 80%, no? Or shall we say, we have 6 times the 5 kilowatt. 6 times 5 kilowatt, and then let us multiply it by 0.8. Okay, so 6 times 5, 30 times 0.8, so 24 kilowatts. That is the maximum allowed by the code. Maximum allowed by the code. Okay, this is more of a board exam orientation, no? Board exam. But if we want to go to a very meticulous explanation, if you want to know my detailed explanation regarding to kitchen equipment, I have a videos, no? Meron tayong video niyan, mga kawerpa. Paki-check nyo na lang po yung mga kitchen equipment, no? Sa aking YouTube channel, no? Type nyo lang yung Reggie Marinay, then you type kitchen equipment, no? So, lalabas na po yung aking video. I have around 3 hours lecture on kitchen equipment. Okay? So, you can download that. That's yours. Okay? For free. Wala pong bayan yan. Okay? So, for the basis of knowing this kitchen equipment, no? So, medyo madugo po itong mga tables na gagamitin natin dito, no? One of the most complicated tables ng dinidiscuss ko po dito sa ating kitchen equipment. Paki-download nyo na lang po. Nasa ating YouTube na po yan, mga kawerpa. Libre lang po, no? Panoorin nyo na lang po yan, no? Okay? Especially if you are, let's say, a design engineer, you can take a look at that if you want to make your work as based on the Philippine Electrical Code. That will be the best, no? If we follow our code, of course, that will mean safety, no? Installation is safe if we are going to follow our Philippine Electrical Code. Okay? So, thank you for this question, Mr. Reblando. Salamat.
Recording stopped. Recording in progress.
Okay, so we have a question from Mr. Jason Reblando. Okay, his question is this: an outlet dedicated only to supply 4 loads Okay, so 250 watts. Is this really 15 or 150, no? So, I'm quite curious, no? So, you just have to add here, no? No problem, I'll just teach you the principle, no? 250, 15, 100 watts, 200 watts. What will be the minimum size of conductor in the outlet? Minimum size of conductor in the outlet. Okay. So, in here, it's just like the outlet dedicated to supply 4 loads, no? So, what will be the minimum size? An outlet. So, you just have to add, no? What will be the minimum size? So, the current is simply equal to the power divided by the voltage. So, you just have to add all, no? I-add natin, ha? Let's go straight here. So, we have here 250 plus 15 plus 100 plus 200. The answer is 565, tama? 565 watts. So, there's no given voltage. So, I presume this is 230 volts, which is the nominal voltage. 230 volts. So, this is divided by 230 equals. So, our answer here will be 2.46 amperes. Okay. 2.46 amperes. So, this one. That will be our answer, no? But our basis is what will be the size, no? So, okay, take a look here. Okay. So, take a look here, this one, no? So, this is from page 174 of the code, no? From page 174. So, we have for PEC 2017, so we have okay. There is no type of conductor here, whether it is copper or aluminum. So, I will assume this is copper. Okay? So, ganun din sa board exam. Pag walang given, automatic mo muna na copper yon. So, let's say TW. For TW, the ampacity is 15. See? From page 174, no? The ampacity is 15 ampere. So, actually, that is already the minimum, no? Kayang-kaya na, 15. 3.5 is 20, 5.5 is 30, 8.0 is 40. So, kayang-kaya na ng ating, ano yan, 2.0, no? Which is 15. No? So, 15 ampere. You just only calculated 2.46. Kahit gawin mo pa itong 150, yung 15 mo, pasok pa rin yun. No? Okay? So, ganun pa rin. So, the minimum size, no? The question here, what will be the minimum size? No? So, that is indicated to your question. The minimum size here. If we are talking the minimum size, my answer here is 2.0. That is the minimum size. It can carry these loads. No? Hindi naman ganun kalaking load mo. Wala pang 1,000 watts yan. No? 2.0 square millimeter. No? Let's say TW or THW. No? So, that is my answer. No? Now, in the design stage, no, let's say you are in practice. No? Usually, what is being done in practice is the minimum for outlet is 3.5. No? In practice. But if you are talking of board examination, you have to be bookish. Sometimes there is a different perception between in practice and in the board examination. In the board examination, you are more of a theoretical, right? Or bookish, shall we say. Okay? So, we have no choice because that is being written in the code. No? So, the question is the minimum size. Minimum size, I would go to 2.0 square millimeter. And that will be my answer. Again, my way of answering is, there are two types way of my answering. No? of course, we cannot force you to believe with us 100%. Of course not. Of course. We may be wrong, no? At some point, no? But in many points, we are right. I would say that, no? No? So, okay. What do I mean? If I mean type 1 way of answering, meaning I'm really 100% sure of my answer. Because sometimes it is just a copy-paste from the book or from the code. Hindi ka na pwede magkamali. You will never go wrong because that's only copy-paste, right? That's only copy-paste. No? But now, if there are some questions that need an analysis, I would say my way of answering is type 2. That I may be wrong. I will admit this. I will admit this. No? Napapanood tayo sa Facebook, no? Sa YouTube. Okay? So, pwede naman po kaming magkamali, mga kawerpa. You can put your comment below. Okay? So, it's really possible. That's why I'm giving you a challenge. Anybody, we are giving you a challenge to study hard. Okay? So, we may be wrong. But I would say, if there are to put some percent error, maybe just a 3 to 5% error. But it's just a few. No? Kasi baka sabihin nyo sa akin, lalo na kung tinitesting nyo lang kami, no? Sir, iba yung sagot sa reviewer. Ito yung sagot ng author ng libro. Ito yung sagot. I don't care about it. I don't care about that. No? I will give my answer as if I am the one taking the board exam. Did you get my point, Mr. Reblando? What do I mean? Sasagot ako, iniisip ko, ako mismo, personally, yung nagbo-board exam. Doon ko nilalagay yung sarili ko. No? I will not be affected from your book, whether sa mo, lupalop kinuha tong mga tanong na to. Sir, iba sagot ng author. I don't care about it. I will answer what I know is right. I may be wrong, but I am correct the way I believe with it. No? So, maybe more than 90% overall, I would say we are accurate. We are accurate. I already uploaded, we uploaded more than 300 videos. In the mentoring program, less than 200 videos in the mentoring program. More than 170 or 180 videos. Those 180 questions I already answered. No? I would say, baka maswerte na 3 doon na mali ako siguro eh. No? Hindi ko no? Kasi pwede pa rin. Ayoko kasi sabihin na, uy, perfect ako ha. Di ba? Galing-galing mo naman, George. Ang perfect mo naman. Di ba? I don't want to be like that. That is being hypocrite. No? I'm not hypocrite as that. No? Hindi tayo hipokrito. So, that is why I am saying this. Kasi baka sabihin ng iba, ayan, inaamin niya, pwede siya magkamali. Di ba, no? Partner, no? Pwede naman talaga. Possible. Di, kung sa tingin niyo, di ba? But for this case, no? I may say, my answering way, my answer here is a type 2 answer. If I mean type 1, I'm 100% sure that I am correct. But I will not say that every now and then, every question's being answered. Para naman tayong no? Every time. Well, it's up to you if you will believe it or not. Right? Just like REE, please. Believe it or not. Okay? So, okay, did you get my point, Mr. Reblando? No? I am putting myself to you in your shoes as if I am the one taking the board exam. Meron nga, nirerentahan ako eh. Sir, baka pwede ikaw mag-board exam. I will pay you 200,000. Ikaw ang pumunta doon. Sabi ba naman? Biro mo, kasi medyo hawig ko siya eh. Pag nakita mo, mukhang bumbayin din eh. No? Baka pwede sir, ikaw na lang mag-exam para sa akin. Bigyan kita 250,000. Sabi ba naman sa akin? No? Magte-take daw ako ng RME board exam niya. Sabi niya. no? Kasi galing siya ng barko, may dala daw siyang 3 milyon, no? Kahit kalating milyon, babayaran ako nun eh. Kasi nung nakita niya, medyo hawig kami. Sabi niya, gusto mo, sir, ikaw na lang ang mag-exam. Sabi, bigyan kita ng 250,000. O kulang ba? Hindi ako pumayag eh. Dagdagan mo. Of course not. No? Hindi mo sisirain mo yung kredibilidad ng powerhouse. Milyon ng powerhouse. Okay? So, ganun po mga kawerpa, no? So, okay? So, I will still, no, consider, no, we can have a mistake at a very few questions there, no? So, that's not, I'm just being real, no? Nagpapakatotoo lang ako sa inyong lahat, okay? So, it's up to you. Nasa inyo na po yan, if you will believe it or not. Okay, salamat Jason to your question. Thank you.
Recording stopped.
Okay, another question
Recording
by
in progress.
Mr. Reblando, Jason. Okay, this question again, I will give you my type 2 answer. No? Parang pangit naman kung every now and then sasabihin mo, to type 1, to type 2. Diba? So, still, okay? Okay, so the presence of current is only made known by the effect it produces. 3 important effects are, what are the 3 important effects? Okay, for me, my answer is heating, electric shock, and generation. So, what do you mean by generation? For me, generation is, so, let's say, nakuryente ka, no? Nakuryente ka, during na nakuryente ka, tapos may napahawak sa'yo. Nakakapag-generate ka rin ng voltahe sa sarili mo eh. Makukuryente, pati yung ano mo. Kaya dapat, anong first step na gagawin mo? Nakukuryente siya. Hilahin mo, biro mo, nakukuryente na nga, hilahin mo. Ang gawin mo, i-turn off mo yung switch, di ba? Punta ka dun sa panel board, i-turn off mo. Nakukuryente na nga eh, hihilahin mo pa, madamay ka pa dun. No? Because you are also a conductor, no? So, you are capable of generating voltage also, no? Of course, electric shock, electrocution, heating, okay, that may burn your muscle, no? Even your artery, your heart, no? That may affect. Okay? That is my answer to your question. Thank you, Mr. Reblando.
Recording stopped.
Okay, mga kawerpa, so hanggang dyan na lang po ang atin pong pagtuturo ngayong araw na ito, no? So, pero huwag kayong mag-alala, no? So, meron po tayong ipapanood po sa inyo na ating pong lecture video, no? About power factor correction. Hindi pa po namin na pakita po ito sa inyo, itong video na to, no? So, this is about energy saving, no? Kung paano tayo makakatipid sa kuryente, no? So, maaaring hindi po matapos ito ng 1 oras, pero at least magkaroon na po kayo ng idea, no? Ito nire-request din ng ilan nating mga kawerpa. At mga kawerpa, ganito po, starting next week po ay i-adjust natin ng konti, no? Dahil kami po mayroon ding adjustment na pag-meeting, no? Gagawin po natin mga kawerpa ay tayo po ay magpapasimula ng 2:30, no? Starting next week, no? And that will be what date, partner? March 8. Okay. Starting March 8, adjusted po tayo sa 2:30 p.m. to 5 p.m. only, no? Because we have a meeting at around 5 p.m., no? So, okay, mga kawerpa, so 2:30 tayo, starting March 8. Yan, sa mga umaattend sa ating parate para well-informed. Anyway, ang detalye naman yan nasa ating Facebook account, ano? So, starting March 8, 2:30 to 5 p.m. po tayo. Okay? So, para mas mahaba-haba po ang ating mga pag-uusap. Ano? But for the meantime, ayoko rin naman pong sayangin ang inyong panahon. So, we still have around less than 1 hour. Ipapakita po namin sa inyo, no? Kasi alam namin na nag-aantay din kayo ng mga lectures, no? Pero ito hindi pa namin na ipapakita, no? So, pwede nyo pong panoorin, ano? Okay, so dagdag kaalaman po ito, paano tayo makakatipid sa kuryente using capacitor banks, okay, for our building. Okay, so hanggang dito na lang mga kawerpa. Okay, Sige, so next time na lang tayo mag-marketing. Okay? So, yung mga gusto pong mag-avail ng aming early bird promo, no, nasa Facebook po namin yan, no, yung mga for September board, for April, pwede pa pong humabol, no, yung ating mga kawerpa para sa April board exam, no, pwede pa po yan. Pagkatapos po, ano po, meron po tayong self-paced, no, anytime you want, no, kung wala kayong time mag-review, pwede pa rin kayong mag-review kahit anong oras na gugustuhin ninyo. No? So meron po tayong mga ganyang mga services na i-offer po sa inyo mga kawerpa, no? And pakitignan na lang po, no, ang ating Facebook account. Nandun po lahat ng details ng aming mga offerings, even yung mga free natin. At abangan nyo this coming Sunday mga kawerpa, no, abangan nyo, kami po yung mag-o-open ng scholarship program, no, sa pakikipag-ugnayan po namin sa UN Television, no, sila po ang magi-sponsor po. We will be opening the application, no, kami po itatanggap ng 100 scholars applicant, no, partner. Okay, so kami mag-a-approve po ng 100 scholars, no, para maging scholar po kayo sa REE, RME, even sa Master Plumber Review, mag-o-offer po kami ng scholarship program on the review course. No, 100% scholarship na wala po kayong babayaran sa ating review course. Ayan. Okay? So, 100 slots po yan, no? So, pwede po kayo mag-apply. So, abangan nyo po ang detalye niya, no? Sa Sunday, sa ating free webinar, no? At saka pala, no? I-advance na natin, partner. This coming Sunday po, ang amin pong free webinar po mga kawerpa ay about the PEC 2017, the provision on short circuit calculation. Yan. Ilalive po natin yan mga kawerpa. Live na live tayo this coming Sunday po. No? Ilalive po natin ang ating free webinar. Pag-usapan po natin ang short circuit calculation na nakabase sa Philippine Electrical Code 2017 edition. Marami pong salamat mga kawerpa. Stay safe. God bless you all. Thank you. Okay, antabay lang po sa ating pong lecture video on power factor correction. Antabay lang po. Sana wag muna kayong mag-leave dyan mga kawerpa. Okay. 10 to 15% goes where? NGCP. NGCP. What do you mean by NGCP? National, okay, National Grid Good afternoon, guys. Magandang hapon po sa inyong lahat. Okay, pasensya na po meron tayong konting generation. Actually, ang laki niya, mga around 45 hanggang 55% yung nakita ko, no? Doon sa aming electric bill. Okay? Yan. And then, alam niyo bang napupunta sa Meralco? Malaki na yung 25% in the utility, no? Maybe around 15 to 25% approximately, no, goes to distribution, and this is the utility charge. Distribution. No? But when the energy cost increases, we blame the utility company. No, inis tayo sa Meralco. Kaso na naman, may yaman na naman si Lopez, di ba? Hindi na pala si Lopez na yun ang may-ari, o si ano na. MVP na, no? Meralco. And then, around approximately 10 to 15% goes to NGCP. NGCP. What do you mean by NGCP? National, okay, National Grid Corporation of the Philippines. National Grid. I'm sorry, that's wrong spelling. Okay. So, National Grid Corporation of the Philippines. Transmission niya, siya yung dating Transco, di ba? They are the one transmitting the power. Okay? So, napakalaki ng generation charge, no? Malaki yung generation charge na binabayaran natin. Ang napupunta lang sa Meralco, huwag tayo mainis sa utility, no? Do not blame the utility. So, it's only 15 to 25%, no? Goes to the utility company. More on the generation charge. No? Who has a copy of the electric bill here? Can I borrow? I just don't have an electric bill. I just want to show to you that the distribution charge is very low compared to the generation charge. Do you have a copy? May I borrow? Pero naman, kahit na disconnection lang. Okay, wala. Okay, sige. Hindi, sige, okay lang. Hindi, okay lang. Nag-joke na kayo. Okay. Eto, pansinin mo ito. Okay. Mahal lang ano nito. Ang mahal ng kuryente niya, 237. Adjusted. Bakit ganun? Ang tindi ng generation charge mo, the generation charge is 95%, transmission 16%. System loss, 9.88. Tapos mayroong subsidies, may mga deduction. I don't think it's a good, electric bill. You keep this. That is not under normal condition. Okay, so this is the usual. Actually, guys, that is the usual. Hindi po bawal ang power factor correction. Hindi po bawal magkabit ng energy saving device. Hindi po bawal yan. Okay. May mga lumalabas lang ng mga binibenta sa SM, sa hardware, no? Nakita niyo yun, is that true? Okay. Ang masasabi ko, kung pwede siyang totoo, pwede hindi. Okay? Ang tutulong ko kasi sa inyong power factor correction is the one usually being used in the commercial and industrial building. That we will discuss, the principle and application of that. But the one in for residential, although I would say the principle is applicable also, it can be done, but the proper design consideration must be taken, no? With the correct computation of the microfarad, of the capacitor. So many factors that we have to consider at home, no, for residential. Okay? But sa mga commercial and industrial building, it is being applied. And in the distribution line, no, that is being applied. Meralco also has a power factor correction device, no? You see this? That is in the distribution line. And this is in the building. Yung mga ginagamit natin sa building, no? So, commercial and industrial building, no? Yan. Hindi yan yung capacitor na ano ha, yung sa ECE, yung electronics, yung electrolytic ha. Hindi yun, hindi niya kayang mag-correct ng ano, di ba? Ng power factor. So, punta po tayo dito. What is power factor? Power factor is the ratio between the kilowatt and the kVA drawn by any electrical load, where the kilowatt is the actual load power and the kVA is the apparent load power. Okay, question. What power, basically, what power we are getting from the utility company, from Meralco, let's say, in Manila? Okay? Are we getting the kilowatts, the kVA, or the kbar? Dapat doon muna tayo magkasundo. Let us agree this. Okay? Yan. So let's say this is your transformer. What is the rating of your transformer? That is, let's say we have 10 kVA. That is in terms of the kVA now. So, in AC circuit, no? So this is your S, this is P, and this is Q. So this is your theta, right? That one. So, power factor is cosine theta, right? Okay. So, this is adjacent over hypotenuse. So, we have your P over S. So, our P is our kilowatts, let's say, and this is our kVA. Okay? Now, kilowatt over kVA. So, ano ba ang power na kinukuha natin from the utility? What power being delivered to us? To be specific, kilowatt, kbar, or the kVA? Actually, we are getting the kVA. This is what we are getting. So, the utility company, or let's say the power plant supplies the kVA. If you are getting the kVA, this is the kVA, the S, right? You are also getting the kilowatt. You're also getting the Q. So, yung dalawa na yung kinukuha natin yun. Okay? Kinukuha natin si P, kinukuha natin si Q. So, dalawa yun. Basically, yung P, bakit natin kinukuha si P? Yung P, siya yung kinukuha ng mga resistance ng mga equipment natin. Lahat ng equipment natin may resistance. No? Yung Q, siya naman yung power na kino-consume, that is being consumed by our inductors and our capacitor. Well, basically, no, most of our building, or I may say all of our building, no, are lacking power factor. Not unless there is some, what do you call this, overcompensation, meaning there are a lot of capacitor banks so that their power factor will become leading. So, in a normal condition of a certain building that is inductive, no? Not unless you put a lot of capacitor banks. Okay, you just let us take away all the capacitor bank. All buildings are inductive. That's it. Okay. Now, so this is the theory cosine theta P over S, kilowatt over the kVA. It says here that it is a measure of how effectively the current is being converted into useful work. So yung daw kuryente, we can convert that, no, into useful work output. And more particularly, is a good indicator of the effect of the load current on the efficiency of the system. So meaning, the power factor correction, it has a relation with the efficiency of the system. Actually, if the power factor ranges from 0 to 1, right? There's no power factor greater than 1. There's no power factor that is negative. Okay? That is just ranging from 0 to 1. Now, this is the relation. If the power factor increases, the efficiency also increases. Okay? If the power factor decreases, the efficiency also decreases. Now, how can we say if the efficiency is high or low? Kailan ba natin masasabi na high efficient yung isang system o isang building, o isang equipment? Kailan ba natin masasabi yun? Nakatingin tayo doon sa power quality. Yung quality ng power. Para mas madali sa voltahe. Pag maganda ang voltahe mo, ano ba sinasabing maganda ang voltahe? Yung voltahe, pagka ang voltahe mo 230 volts, sabi ng Energy Regulatory Commission, do not exceed plus or minus 10% of this. So what is the upper limit? That is 1.1 times 230. How much? You can use your calculator. If your calculator, the better. How much is this? 253. Is that correct? 253 volts. And the lower limit is 207. Meaning, the fluctuation in the voltage, no, must be ranges from 207 to 253. I'm sorry, we should not include this one. So let's say this will just show the fluctuation of these voltages. Let's say the lower limit, let's say this is the lowest point. That should be 207. And then as high as 253 only. This is being set by the Energy Regulatory Commission. Set to Meralco. They said to Meralco that your fluctuation must only be plus or minus 10%. Okay? So what will be the effect? The system will become low voltage and high voltage. Ano ba ang epekto? What will be the effect pagka low voltage? Well, if there is a low voltage, di ba, pagka low voltage, what can you say about the lighting system? So it's dim, no? So hindi maliwanag, it's not clear. Okay? Yung speed ng motor mo, mabagal. No? Yung aircon mo, hindi masyado malamig, no? Pag mababa ang voltahe. O pag mataas, kabaliktaran. Oh, bilis ng ang bilis ng electric fan, yung andar, wala, nag-high voltage kasi yun. Uy, ang lamig nasa white pool, parang turbo ko lang. Uy, ang liwanag O, maya-maya, puputok na yan. No? Okay? Puputok na ngayon yan pagka nag-high voltage yung system, no? Now, nakakatulong ang capacitor sa mga fluctuation na yan. Pag may capacitor ka, ito pa advantage ng capacitor, ha? A capacitor is a voltage regulator, no? If you have a lot of fluctuation, the capacitor will reduce this sudden increase or sudden changes in the value of the voltages. I remember my student, no, sabi ng estudyante ko, 3rd year pa lang. So, sir, bakit gano'n sa amin sa probinsya, ang baba ng voltahe namin? No? Baba daw ng voltahe daw nila sa probinsya. Sir, 180 lang ang voltahe sa amin. Ang una tanong ko kagad sa kanya, may idea na kasi ako kagad Sir, bakit po ganun? O, halimbawa ba, ito ba yung poste ng utility? Let's say that is the pole. That's one. Then you have your transformer here. So, nasaan ba yung bahay nyo dyan? Ito yung poste, ito yun. Nasaan ba yung bahay nyo dyan? Sir, nandito yung bahay namin. Ayun, hayaan naman pala 2 kilometers from the pole. That's why you have a 180 volts. you may say that if you have a high efficiency system, meaning you have a good voltage. Okay? You have a good voltage. Mataas ang voltahe mo. Ibig sabihin, that is near to your nominal voltage. No? Or even a little higher than that. Okay? So, you only have 180 volts here on your house. Tapos ito naman yung ano mo, ito naman yung poste mo ng Meralco. Ang haba ng service drop mo masyado, right? What is the number one factor kaya bumaba ang voltahe? Voltage drop. That is too long. So you have your voltage drop here. This is your R. This is your I, right? Let's say you have your voltage of the source. Let's say this is your source side, no? And then this is your line side. Just like in the DC circuit, no? This is how you represent this. Let's say there is a battery here, then there is a load here. This is your house. That one, this is your house. So, the voltage of the load here is 1. And then you have your then you have your I. Then you have your voltage of the source. Okay? Do not use Kirchhoff's law. Just use chop-chop law. What is chop-chop law? This is the chop-chop law. The voltage here plus voltage here is equal to the voltage here. So we have here BL plus what? IR. So yung voltahe rito, the voltage here plus voltage here is equal to the source voltage. Okay? So, ganun po yan. Meaning, malaki ang voltahe. There's a big voltage, no? Being eaten. Being eaten. Sabi kasi ng electrician, sir, laki ng voltahe kinakain ng wall. Okay? There's a large amount of voltage being eaten by the wire. Bakit? Sabi eaten, kinain daw to. Okay. There's a big voltage, no? Being consumed by the conductor here. No? Okay? That is why 180 volts lang. No? How do we, so that we can understand easily, how do we understand voltage drop? Ano ko ba yung isip? Oy, eto. Eto, 100. This is 100 pesos. You give it to your brother, ha? You give the 100 pesos to your brother. But he only received 70 pesos. Muhammad. I give 100. I'm their father. I'm the father. This is the 100. You give this to your brother, huh? He's like your small brother. He only receives 70 pesos. Where is the 30 pesos? Voltage drop. Right? You see? Napakinabangan ba niya yun? Did he use the 30 pesos? No. Saan napunta yung 30 pesos? Sa bulsa niya. Kapapan mo. Sa kanya yung 30. You see? That is the voltage drop. Hindi niya napakinabangan nung dapat puntahan. Nawawala yun. Ito, alam mo kung saan napunta? Sa linya. Siya, sa bulsa. 5-6 yun. 5-6. Okay. Ayan ha. So ito ha. Okay, hindi mabumbay siya. Kaya talagang mabanggit yun ng 5-6 dito ha. O ito yan ha. This is now your IR. The IR is the voltage drop. Siya po yung voltage drop. Voltage drop. You see? That is the voltage drop. Okay? Now, take a look. Take a look. I will multiply this by I. No? I will multiply the equation by I. This one, multiply ko lang siya ng I. So, the equation would be Bs times I will be equal to Bl times I plus I squared R. Right? Right? Right there. Right. Okay. This is what we call the power input. That is the input of the utility company to your house. Huh? Okay? Clear? Okay. What is this? BL times I. This is your Power output. Okay, very good. There is a plus here, so put here plus. What is this? This is a popular formula of what? Power loss. So meaning, actually the power loss is 1/10 of our system loss. Binabayaran natin. We are paying for the system loss. Okay? So, this one. Okay, let's get the efficiency. What is the efficiency? So, efficiency is equal to power output over power input, right? That's the basic formula of efficiency. So, this is power output over power output plus power losses, right? Because power input is power output plus power losses. Now, this is now your efficiency. Okay? So, we have the voltage drop here. We have the voltage drop. Your power loss will be equal to what? The voltage drop multiplied by I. Isn't it? Okay. Let's take a look at the power loss. That is voltage drop multiplied by I. If I am going to reduce the voltage drop, no? Okay? That is the voltage consumed by the line. Okay? If I will reduce the voltage drop, what can you say about the power loss? That will also decrease also. Di ba? Pag pinabaan mo yung voltage drop, bababa din yung power loss. Okay. Pag pinabaan mo yung power loss, kasi bumaba yung voltage drop na, di ba? So, kumonti yung drop mo doon sa lina. So, bababa din yung power loss. Pag bumaba yung power loss, ano mangyayari ngayon sa efficiency? Tataas. So, high efficiency system. Okay? So, ibababa mo yung voltage drop. Yan. So, ito ang ginagawa ng power factor correction. No? One purpose of power factor correction is to reduce the losses. But how the capacitor will reduce the loss? So later I will discuss that into detail. So what I mean is, let us establish this first. Because I've given to you the power factor is directly proportional to the efficiency. Dito muna tayo. No? Pag sinabi natin high efficient, if we say high efficiency, meaning you have a high voltage, a good voltage. If you have a low efficiency, meaning you have a low voltage system. Of course, if your voltage is too low, just like that one, 180, meaning you have a high voltage drop, right? Okay? I say voltage here, this is the voltage, no, at the load. I'm referring to the voltage at the load here. Okay? If the voltage at the load is higher, meaning you have a good efficiency. Doon mo lang naman nakikita, that's the only gauge that you can say that you have a good power quality. Meaning, if you have a good voltage, pag maganda ang voltahe mo, no? Ibig sabihin na magandang voltahe, kung binigay sa'yo ng Meralco 230 boss, sana ma-utilize mo yung buong 230. Yun ang maganda. Nakuha niyo? Kasi may epekto nga di ba? Pag mababa ang voltahe. Okay, sige. Babalikan pa rin natin yan later, ha? So, introduction lang yan. So, punta tayo dito. The higher the power factor, the more effectively electrical power is being used. Yun na nga, di ba? Pag mataas ang power factor, more effective ang electrical power. Okay? So, pag mataas ang power factor, sir, paano ang nangyari yun? Kailangan pataasin yung power factor para maging efficient. Ayan. Isa-isahin natin yan. Ito muna tayo. What is power factor? Power factor is a measure of the degree to which a given load matches that of a pure resistance. No? So, what is the characteristic of a purely resistive load? A purely resistive load has a power factor of 1. And 1 is the unity. That is the maximum. Right? Although I would say the unity power factor I'll give to you the ideal power factor. This is the ideal power factor based from my experience, 92 to 96%. That is the ideal power factor in the building. Ideal power factor. Sir, why is not 100%? No? So, why is not 100%? If we will make this as a 100%, take a look, huh? So, our P that is equal to your S multiplied by cosine theta. Or S that is times power factor. So, if I will make the power factor as 1, so therefore, P is equal to S. Meaning, this kVA will become what? Kilowatts. They are just equal. Question, is there a Q? Meron wala. Is there a Q? No more Q. Because S is absolutely equal to P only. When? If the power factor is 1. Now, what is the importance? No? Okay? We need a little Q, just like sugar. We need a little sugar. The doctor would say you drink a wine. That's good for your heart. Need a little alcohol. Right? So, kailangan daw may konting pampasipa daw yun. Red Horse. O, ayan. So, we need a little Q because that Q is being consumed by our inductive load. We need that power, a little. Konti lang. Kailangan mo ng konting Q. Para saan? Para ma-utilize mo yung mga inductors mo. Gumana properly yung mga motors mo, no? Yung mga inductive lighting system mo, may ballast yan, no? So, gano'n. Yung mga appliances ko basically are inductive, no? So, kailangan mo yun. Tandaan nyo, ulitin ko lang, ang kinoconsume ng mga resistors natin, yung watts. Ang kinoconsume ng mga natin, coil, no? Are bars. The Q. These are the bars, right? Bars. And these are the watts. And this is our kVA. Or volt ampere. Okay? kVA. That one. Okay? So, we have power factor is 0 if load appears as L or C. No? So, ang power factor daw natin, 0. Kung yung daw load natin, purely L or C. No? If that is pure L and pure C, power factor is 0. For RL, power factor is between 0 and 1 lagging. For RC, power factor is between 0 and 1 leading. I remember when I was faculty member of QE Caloocan, we had an experiment called as a power factor correction. So we have this setup. No? We have this setup. We have a wattmeter here. We have an ammeter. Then we have an inductive load here. We have a voltmeter here at the line side. Let's say VS, then we have the VL at the load side. Let's say somewhere here, the VL. And then we have a capacitor here, variable capacitor. So that one. Okay? And we have here a power factor meter. We even have here power factor meter. Yan, power factor meter. So we increase the capacitance, no? In the experiment, this is the result. As we increase the capacitance C, the microfarad, as we increase the microfarad, the power factor also increases. That is the conclusion, no? This is the power factor meter. This is the power factor meter. What is in the middle?
1.0. This is 0, and this is also 0. This is 0 lagging. This is lagging. And this is 0 leading. Yan. Now, this is the pointer. Let's say, pinagin namin to. Okay? Initially, we don't have a capacitor yet. So there's a certain power factor. Let's say that's too low, 0.3. 0.3 lagging. And then, when we put, or when we connect the capacitor, across or in parallel with respect to the load, this is your inductive load. And then, as we increase now the capacitance, we saw that the power factor meter becomes, the reading becomes 0.4, 0.5, 0.6, even it reaches the 1.0 here, so therefore the system becomes purely resistive. It becomes at resonance condition. Now, it has also a tendency na maging leading. The system can be a leading power factor. What will be the effect? There is an effect. If the system becomes leading, pag naging leading yan, let's say for leading power factor. For leading power factor, your load voltage, this is your load voltage. Your load voltage, it becomes greater compared to your source voltage. Di ba baliktad? Ano ba ang usual? Di ba sino mas malaki? Si BS o si BL? Siyempre, mas malaki na BS is greater than BL. That's the usual because there's a voltage drop here, right? Okay, but if your system becomes leading, that is what we call the overcompensation. Your load voltage becomes greater compared to your source voltage. Okay? So, mas malaki po ang voltahe sa load kumpara doon sa source. And that is what we call what? Remember this, ha? Lumabas na ito sa board exam. That is what we call the Periphery Effect. Okay? The load voltage becomes greater than the source voltage. Nakuha? So, ganun. Mas malaki yung source voltage mo. What is the usual? Of course, the source greater than the load. Because of the voltage drop. But, you can increase the voltage of the load as long as you have the capacitor here. If you have the capacitor, you can increase the voltage here. Okay? So, that's why there are buildings that they have the capacitor banks. What will be the effect? This is not a good phenomenon. That's not a good effect. There are capacitors becomes pregnant. Stable capacitor becomes pregnant. There are capacitors that is cylindrical in shape. It becomes like this. Okay? You take a look at this, Muhammad. It becomes pregnant. Something like that one. That one. Tumatabay dito. Kakaroon ng tiyan. Pagka yan parang nabubuntis yan, nag-overvoltage yun. Dapat i-disconnect mo na siya sa line kasi puputok yun. Pwede sumabog po yun. So, ganun. Okay? So, ayan. So, let's continue. Okay. So, we have most of the loads on electrical distribution system can be categorized into three. So, yun na nga. So, we have the resistive, we have inductive, and we have the capacitive. Okay? So, on modern system, the most common is the inductive load. A typical example includes transformer, fluorescent lighting, and induction motor. If we mean inductive load, so there is a presence of coil, wire wound, coil yan, okay? So, a common characteristic of these loads is that they utilize the winding in order to operate. Ayun. So, they utilize the winding or the coil, Yung mga inductive load daw na yun. So, this winding produces an
electromagnetic field. No? Yung daw winding nagpo-produce ng electromagnetic field, which allows the motor or transformer to function and requires a certain amount of electrical power to maintain the electric field. No? Let's say you have your motor. There is a magnetic flux in your motor, right? There is what we call the revolving magnetic field inside the motor. If there is no Q, there is no K bar, there will be no magnetic field. That's the importance of the K bar. That's why it is not good to have a perfect 1.0 power factor. You should have a little Q. If you make this as 100% perfectly, there is no Q. Later, I'll show you the phasor diagram. Let's go first to the theory. This is the theory. Take a look here. So for purely resistive load, okay, so this is the voltage, and this is the current, the red one. That is the current. So if we have here, this one, we have a sine wave. I call this as the starting point. You see this one? This is the starting point. Starting point. Okay? That is the starting point. This one. So this one we call in phase, right? I is in phase with P, or P is in phase with I. Okay? That one. Now, going to the positive direction, the starting point of this current is this one. This is the starting point going to the positive direction here. This is the voltage. Which is leading? Is it the current or the voltage here? Sino ang nauuna? Which is the leading? The voltage leading? How did you know? Huh? Okay. Just think of a... The way mas madali. Think of a two runner, or think of a two basketball player. LeBron James and Kobe Bryant. You see the head of LeBron. This is the head of he's taller a little than Kobe. This is the head of LeBron James. This one, the head. There's the head here, and there's another head of also. Okay, let's forget this. Okay. So this is the head of Kobe Bryant. Whose head is nearer to the finish line? So they are running, no? This is the finish line always on the left side. The head of LeBron James is nearer. This is the head, this one. That is side view only, side view. This one. This is the head. So, the head of LeBron is nearer, right? Compared to the head of Kobe. This one. You see? So, sino ang leading? Sino yung leading na una? No? He comes first. If we meet lagging, he comes second. Okay? He comes next. Okay? Hindi na para pag-English. Ito. Ito yan, ha? Nakita nyo? Malapit na ito, di ba? Kumpara dito, di ba? Okay, reading ngayon yung voltage. How to read this? V leads I by theta. No? So, ganito. Sa mga inductive load natin. So, nauuna yung, nauuna? Voltage. Nahuhuli yung kuryente, no? Let us review a little the AC circuits, na? Okay. AC circuit. Naalala niyo ba yung mga leading, lagging, inductive, capacitive, di ba? Yan, pag-aaralan natin lahat yan. At saka yung application. Magandang topic yung yung power factor correction. It's a very nice topic. Why? Bakit isa yan sa pinaka-paborito kong topic? Kasi power factor correction, that is the application of the theory. No? So we can apply the theory here. Even the calculation, I'll show you later. Okay, I think we are already clear with the resistive load, right? The current is in phase with respect to the voltage. What about now the inductive load? If you have an inductive load, 1. If we mean an inductive load, that is what? A lagging power factor. Lagging power factor. So, we have here, so we have the voltage here. Let's say this is the voltage waveform. And then we have the current waveform. The starting point of the voltage, of course, is here. That is LeBron James, right? And then we have the Kobe, this one. Ito si Kobe. Ito. This is I. So this is the starting point. Okay, just take a look at the starting point. This is the finish line. No? This is mirror. No? This is the finish line. This is the finish line. The starting point of the voltage is nearer to the finish line. The current comes next. So, we can say that P leads I by theta. What is the theta? That is the angle between your voltage and your current. Okay? Now, or we may say that I lags P by theta. Na? I lags P by theta. Okay? So, what are the sample of the inductive load? All loads that has coil. Motor, with transformer, with balance, the lighting system, the appliances. Most of the loads are inductive. Now, let's go now to the capacity. Capacity load. This is actually a leading power factor. Leading power factor. Let us have this graph. What will be the position of I? This will be your I, let's say. This is your I. Okay? Then this is now your V. This is your V. This again the starting point. And this is now our theta. Remember that the theta, no, one definition of the theta, okay, that is the phase difference or the angle between the voltage and current. Okay? So this is the finish line. How to read this? Which is nearer? Kobe or LeBron? Kobe, di ba? Yung current. This is now the current and the voltage. What is this? Current. No? Current flowing. Walang ka-social. Ano? It should not be the current. It should be this one. It should be the current. Yan. Lagyan mo pa ng H. Current. No? Just say class, current. Pagkapampangan, kahit wala ng H. No? Di ba? Sino kapampangan dito? Yung kapampangan. Pwede ba ako magtanong sa iyo? Ano ba sa kapampangan ng mahabang tulay? Mahabang pwede. Ganun ba? Ano ka mo? Ano yun? Ayan, okay. Ano ba yung isa? Sisiw pa? Ibon pa lang pagdating doon sa kabilang tulay. Ano na? Yung mahabang tulay doon sa ano, di ba? Okay. Tingnan po ninyo to, ha? Tingnan po ninyo to. Okay? The current leads. Okay? The current. Okay? Do not say the current, ha? The current. The current. Okay. Ano pa call center, di ba? The current, what? Leads the voltage by theta. This is the theory. This is the theory. Or we may say that V, what? Lags I by theta. They're just the same meaning, right? Just the same. Okay? So, if we say I leads, no? I leads, that is leading power factor. Or if we say leading power factor, meaning that is leading current. No? If we say lagging power factor, we say lagging current. So therefore, no, it dictates the nature of the current, not the voltage. If we say lagging power factor, meaning lagging current. Leading power factor, meaning leading current. Okay? It talks about the current. Okay? So that is the basic. No? Yan. So, yan yung theory natin. Do you remember in AC circuit? We're just talking only of the theory, huh? Let us strengthen first our theory before we apply. Okay. Let us recall. Yeah. We have 3 triangles in AC circuits, right? What are the 3 triangles? So we have the impedance triangle. So we have the resistance. We have the reactance here. Right? Okay. This is your S. This is your theta. This is your P. And this is your Q. Okay? Right triangle. And again, what is this? This is your admittance. This is your conductance. And this is your susceptance. And this is your theta. The theta here, of course with the resistive, there's no phase difference. This is the voltage, this is the current, right? The theta is only 0, right? Cosine 0 is simply 1, right? Now, take a look. No? Impedance, power, and admittance triangle. If we have 30 degrees here, all of these are 30. 30, 30, and 30. Only means the same. The phase difference between voltage and current, that is also our impedance angle. That is also our power angle. That is also our admittance angle. Ano bang tawag doon? So, iisa lang yun. Pare-parehas lang ang tawag doon. Now, you see, we have here our Z, right? Then the magnitude of Z, no? Then this is angle, bar angle plus minus theta. Then you have your apparent power S, that is magnitude of S is plus minus theta. Then you have your Y. Your Y is magnitude of Y. That is your admittance, reciprocal of impedance, right? Okay. So this is plus minus theta. No? And then you have your I. I will include the I. Magnitude of I is of plus minus theta. That one. This is theta of the current. That's the difference. Remember this, no? Tandaan nyo ito, class. Ha? Pag nakita nyo, pag positive to, if that is positive, this is also positive, and this is also positive. If that is positive, no? The angle is positive, ha? If that is positive, that is capacity. No? It sounds almost the same, right? Halos parehas lang, no? Positive, positive, capacity. Positive, capacity. Positive, capacity. Just the same, right? Positive, capacity. No? Now, the positive and capacity, that is wrong. In admittance, if that is positive, that is what? Inductive, right? In the impedance. If that is negative, that is capacity. That's the difference. Okay? So, tandaan nyo lang, no? Let us remember, in the admittance, no? Correct? Current power, positive, capacity. No? In current, positive, capacity. Admittance, positive, capacity. In power, positive, capacity. Did you get that? Did you get that? Yes. In positive, capacity. Did you get that? Yes, sir. Yes, sir. Yes, sir. Pag sa admittance, if that is in admittance, if that is in the current, if that is in the apparent power, if positive, capacity. Did you get that? Yes. Yes, sir. You see the yes? You see the yes? Positive is capacity. Okay? Now, let's continue. Those are the theoretical knowledge that we have to remember. Okay. Now, let's see this figure. So, all inductive load require two kinds of power to function properly. So, we have two kinds, no? So, we have the active or real power. That is the kilowatt. What is the work of this? That is actually performs the work. Just like in the motor, so that your motor will have a torque here. There should be a power developed, right? That is in kilowatts. So that it will have a torque, a force here. And then what will be the function of the reactive power or the K bar? Anong trabaho niya? It sustains the electromagnetic field. Okay, so that it will be understood easily. You have your magnetic field in your motor. Let's say north-south, there's magnetic field. Then there is a revolving magnetic field in the motor, right? Okay? Tomorrow, I'll make some discussion about motors, so you attend, no? So, there is a revolving magnetic field in the motor, right? That's why it rotates, that one. There is no physical device that makes this blade rotate, no. That is just purely an electrical, then converted there to a revolving magnetic field. That's why it turns, go around. So it just rotates, right? Okay. That is what we call the revolving magnetic field. Because of that, that's why it is rotating. Okay. Now, ano ang trabaho ni active power? It performs the work. Ano ang trabaho ni reactive power? Sustains the electromagnetic field. Ano ba sa Tagalog yun? Yung active power, para umikot, gumana yung it performs the work. Sa motor mo, para umikot siya ng maayos. Yung reactive power naman, to sustain the electromagnetic field. The magnetic field must be continuous there. It should always be there so that it will rotate. No? Okay? So, we need first the magnetic field before your rotor rotates. The rotor of your motor rotates. There should be a revolving magnetic field. No? That revolving magnetic field, no? Before you have that, you should have an electromagnetic energy. And that one, that electromagnetic field, there should be an energy first. Energy is work so that it may rotate. If we don't have this K bar, that will be lost. The rotating magnetic field will be lost. Will your motor rotate? Will your motor rotate? No, it will not rotate because there's no revolving magnetic field. Nakuha niyo ba? Kailangan meron ka munang revolving magnetic field para umikot yung rotor mo. No? Ngayon, umiikot na siya. Di syempre, it can perform now the work, the function. You may put now your blades there, no, your belt, if you have your conveyor. No? Okay? So that's the function of the kilowatt and the K bar. Now, this is a theoretical explanation for the system with and without capacitor. This is an ideal, I would say, ideal po ito. Let's say we don't have a capacitor. Any building may be represented by a motor. Okay? This is a motor. Let's say this is a building. You are getting the color blue. What is color blue? That is your reactive power. What is the color red? Here, that is your active power. So meaning, this is your active and this is your reactive. Meaning, this is your P and this is your Q. Now, you get the P and you are also getting the Q. So therefore, you are getting the S. Isn't it? Tama ba? Kinuha mo kasi yung P, kinuha mo rin yung Q, kinuha mo yung S, automatic. Right? So, kaya kinukuha namin sa Meralco, sa utility, yung KVA. Hindi sir, kilowatt lang ang kinukuha natin. Bakit ang tawag doon sa metro natin? Kilowatt hour, di ba? Bakit sir, hindi na lang kilovolt ampere hour? Although merong device na kilovolt ampere hours. There's a meter like that. In the building, in the switchboard, switchgear, you will find that. Even in the building, let's say a high-rise building, it has a power factor meter. So you can monitor your power factor. So, with capacitor, so take a look. This is an idea, I would say. The two motor, these two motor are just getting what? The color red. Right? You see, only color red. So, hindi na siya kumukuha ng kulay blue. The capacitor will give you the color blue, which is what? The reactive power. Did you get that? Because the capacitor is a reactive power generator or a reactive current generator. So it can generate reactive power, and it can give you the reactive power you need. No? Yung kailangan mo reactive power, mabibigay sa iyo ng capacitor. Why improve low power factor? Low power factor means poor electrical efficiency. Kailan ba natin masasabi na poor yung electrical efficiency? If the voltage is very low. No? It's very easy. Use the tester. If the voltage is very low, poor electrical efficiency. Okay? The lower the power factor, the higher the apparent power drawn from the distribution network. You see, there's another relation. Let us have this. The lower the power factor, if that is lower, the higher the apparent power, no, drawn from the distribution network. You know this apparent power factor, that is your KVA demand, no, from the utility, from the source. Isn't it that we are calculating the electrical design? Now we are getting the volt ampere of your building, right? Well, if you want to calculate for the size of your transformer, you have to calculate first all the loads, right? That will be the basis on how you are going to size up your transformer and your generator. Right? So it's very important, and you may see that in the load schedules. Okay? You attend the training, huh? We have the training about electrical design. So, manufacturers are often billed by their electric utility for having a large inductive load, okay, at their facilities. In Manila, no, I would say the Meralco franchise area, the biggest utility company in the Philippines, Meralco. So they have what we call a maintaining power factor, a standard power factor that they have to maintain according to the Philippine Distribution Code of the Philippines. No? So, we have, if you go higher than, if your power factor, this is your base power factor based on the PTC. Kung mas mataas ang power factor mo sa 85%, no? Higher than 85%, you will have a discount from Meralco. You will have a discount of 0.3% for every percentage point higher than 85%. So later, I'll show you the detail of the computation. If you go lower than 85%, no? Why you have a low power factor? Because you have so many inductive loads. No? If you have so many motors, especially in the industry, kabit ka ng kabit ng mga motor mo. No? So, if you have so many motors, bumabagsak yung power factor, bumababa yung, kung ito unity, bumababa yung power factor, kaya yung dinrawing ko doon kanina. Bumabagsak yan, pagkabit ka ng kabit ng mga inductive load. Now, if you go lower than 85%, you will have here your penalty, or what we call the surcharge. Ilan ba ang surcharge? That is 0.6% for every percentage point lower than 85%. So meaning, bakit ganon, sir? Sir, why is that? Why is that? The discount is only 0.3%. The penalty or the surcharge, of course, this will increase your electric bill if you have your penalty. No? That is an additional charge if you have your penalty. Sir, why is it, if that is a surcharge, that is 0.6. Pag discount naman, yung mababawasan ka ng bayad mo sa kuryente, bakit 0.3 lang? Ba't ganun, sir? Yung negosyo eh. Magagawa natin. No? Business yan. Ba? So, yun ang sagot dyan. So, okay. So, punta tayo dito sa mas mahalagang. Okay. What are the advantages of having or improving the power factor? If we say improving the power factor, we are increasing the power factor near to unity. Not perfectly unity, I would say. Practically. Ideal only is unity. Okay. Advantages of improving. Okay. Well, there is a dash here. So saving money, of course, that's the most important contribution. Okay. High power factor eliminates utility power factor penalties. So there is a penalty here that can be eliminated. No? Okay? So high power factor reduces the power or the heating losses of the transformer. And I would say other equipment, no? The heating losses of your transformer, generators, your equipment. If you have a high power factor, no? Hindi siya masyadong mag-iinit, no? Okay? So, pag mababa yung power factor mo, the lower the power factor, it will generate more heat, no? Your equipment will generate more heat for a lower power factor. Okay. Let's continue this one. High power factor means high efficiency. Okay, I told you this earlier. High power factor stabilizes voltage level. Again, let's repeat. If you have so many fluctuations, no? Put a capacitor. You have a large voltage variations here. Large variation of voltage. If you have a capacitor on the system, there is still variation, but a little, just a little. Konti lang. No? Okay? It becomes more uniform, the voltage. This is what we need, a uniform voltage. We don't need there's always a sudden changes in the voltage or current. We don't need that. That may damage our equipment. No? That is an unregulated voltage. Kailangan po natin ng voltahe constant as much as possible. DC lang constant di ba? DC Ang AC talaga nagpa-fluctuate yan. Okay? Pero kung may capacitor ka, possible pa rin na gumanda yung output voltage mo kumpara dito. This will damage our equipment. Okay. So, high power factor. Okay. Stabilizes voltage level. This is what we call the stabilization of voltage. No? May stabilize na natin yung voltage. Improves machine performance. Well, as I told you earlier, if you supply that electric fan with a low voltage, what will happen? Slow. It will move slowly. No? So, mabagal lang yung ikot niya, yung andar niya. Bakit? Mababa kasi yung voltahe. If you apply a larger voltage, it will move faster. It will rotate faster. Okay? So, improves machine performance. No? Because you apply the rated voltage, no? If the rated voltage is 220 volts, you apply 220 volts, it will function properly. But if that is 220, then the voltage here is 180, it will not work properly. What will happen to your motor is that if you apply a low voltage here, the tendency for your motor, it will throw a large amount of current. A larger current if you supply this a low voltage. Just like in the transformer, right? In the transformer, the lower the voltage, the higher the current. Sir, dito po, mababa voltahe, mababa rin kuryente. Kay Ohm's law yun. Ang transformer at saka motors, parang parehas sila. No? Let's say you have in the utility, the pole, which has a larger size of wire. Is it the primary or the secondary? Huh? This is the pole. Then you have a three-phase transformer here. This is the three-phase distribution transformer, and this is our high tension wire, the primary line, no? So these are our three distribution. And then you will have here, let's say it supplies a certain building, which has a larger cross-sectional area. Is it the secondary here or the primary here? Which has a larger size. The secondary, the voltage here is around 34.5 kilovolts, line to line. No? That is a high voltage. The lower voltage is around 250 or 240 volts. No? So, this is a low voltage, but it has a larger capacity of wire because mas mababa. Diba? So, yung capacity natin, okay? So, mas mataba yung wire mo, no? Pero yung voltahe mo, ano? Mababa. The lower the voltage, the larger the current in the transformer. That principle is carried by the motor also. If you apply a low voltage in your motor, it will draw a large amount of current, a larger. That is the behavior of the motor. So do not allow your motor be supplied by a lower voltage. No? Okay, so if your voltage is small, so you report that in the utility company. They have something to do, maybe there's something to do with their transformer tap changing. Is their immediate response, no? To change the tap changer of the transformer. Do you know the tap changer of the transformer? It's like a watch with one hand, without a minute hand. So, you see this one? There is 1, 2, 3, 4, 5, and then there is an arrow here. If you increase the number from 1 to 2 to 3 to 4 to 5, that will increase also the output voltage. No? Because the principle there is, this is the principle of the tap changing transformer. So we have 1, 2, 3, 4, and 5. So this is 1, 2, 3, 4, 5. If you go higher tap, this is your load. From 1, go to 2. Let's go to 3 or 4 or 5. This is your load. No? From 1 to 2, which has a number, the number of turns increases, right? Okay? Let's say from 1 to 5. The number of turns increases, right? If the number of turns increases, the voltage also increases. That is the relation in the transformer. No? Did you remember the relation in the transformer? The transformation ratio, do you remember this? Any, E-N-I, any, 1, 1, 2, 2, 2, 3. That is 1 and this is also 1, 2, and 2, meaning they are directly proportional. If we be directly proportional, as number of turn increases, the voltage also increases. If that decreases, the other value also decreases. If this is 1 and this is 2. This is 2 and this is 1. 1, 1, 2, 2, 2, 1. If that is 2, 1, 1, 2, meaning they are what? Inversely proportional. As the current increases, your voltage decreases. In the transformer only, it's not in the Ohm's law. It's different in the Ohm's law. In Ohm's law, I is equal to V over R. The higher the voltage, the higher the current. Because the load here is directly connected to the source. This is now your, let's say you have a variable DC source here. So you have your ammeter here. You have your load here. This is your voltage. As you increase the voltage from the source, the current also increases here. The voltage here increases of the load. Because the load is directly connected to the source. Wherein your transformer, your secondary is not connected directly to the source. There is a transformer here. There's transformation going on here. Okay? So, that one. So, okay, another thing is increased system capacity. What do you mean by increased system capacity? Let's say, for example, we have two buildings. For example, we have building A. We have building B. So increase system capacity. So this building without capacitor. And this building has a capacitor. No? Let's say, for example, they have an electric bill of 1 million. Sir, their electric bill is the same as 1 million pesos. What's the advantage? Let's say, two identical buildings. Let's say you have well, identical only in the electric bill. You have 1 million pesos, 1 million pesos. No? With capacitor, without a capacitor. If this is your dalawang building yan, di ba? So, yung dalawang building na yan, ito dalawang building na to, 1 milyon to, ito 1 milyon din. Oh. Pero sir, bakit parehas lang naman ang presyo niya, di ba? Parehas lang ang presyo niya. O ngayon, sir, wala namang advantage eh. Ano naging lamang yan? Naka 1 million ka nga rito, pero mas marami kang load to. O ngayon, mas marami siyang dalaga ng load. Ayan, di ba? Ayan. Ha? No comment. Okay. So, parehas lang na 1 million na electric bill, pero mas maraming kargang load to. Naintindihan? Naintindihan? O assume, parang ganito, assuming parehas sila ng load, identical, kambal yung dalawang building, kambal. Alam niyo ba, wala talaga yung, sa mundo talaga walang perfect link kambal. Diba, kaya ginagamit sa pag nag-iimbestiga sa question document, thumb mark. Walang dalawang taong parehas ang thumb mark. Okay ba? Ba? Pero assuming na parehas sila ng load. Ito walang capacitor, ito capacitor. Kung parehas sila ng load, mas mababa electric bill nito. Kung ito 1 million, ito 999,999. Mas mababa na piso, ayun ba yun? Pwede na. Hindi. Ang sabi ng mga energy saver manufacturer, pwede ka makatipid as much as 30 to 35%. Na? Yan ang sabi. I don't know kung napanood nyo nung araw yung commercial sa TV, yung mga TV shopping lang siya. Yung merong motor dyan. Matagal na yun eh. Siguro 10 years ako pa yung kinumercial. May tayo man, siya daw. Naintindihan ko eh. Mga 15 to 30% daw nakakapitid. Hindi naman ako Chinese. Siyempre meron dito kami subtitle. Meron siyang motor doon. Pag kinabit yun, bumabagal yung metro. Kita namin, bumabagal. Is it possible? That's possible. Pero there are more engineers who do not believe with that. Ako, pwede akong maniwala doon. Basta tama yung pagkaka-compute, ha? Basta tama yung computation. Pwede akong maniwala doon. Bakit? Kasi na-apply na naman doon sa mga building eh. Di ba may capacitor banks yan? Yun lang naman ang ginamit na principle doon eh. Nung inimbento yung gadget. Yun lang na ginamit doon na principle. No? Okay. So, okay, let's continue. Okay. So this is the current triangle. As shown here. So this is the motor current. So there are two components of the motor current. There is a magnetizing current. No? This is the magnetizing current. No? This is actually the reactive portion, and this is the active portion. This one. So, kumbaga, this is the x-axis and this is the y-axis. No? It's like in the mechanics, right? So, in mechanics, so you have your force here. This is your force. This is what? Your f of x. And this is your what? F of y. Okay? So, I will explore more this triangle. Okay. Okay, so let us try to imagine we have a load here. May load tayo dito. There is a load here. Your load, no, takes a current from the source. This is your IL. Okay? This is your IL. Load current. No? Now, where is your load current here? Let us draw the phasor diagram. This is the load current. The IL here, this one. Use your calculator later. Huh? This one. Ito siya. So it has two components. This is the x-axis and this is the y-axis. This is the active component, this is the reactive component of the current. Okay? Now, let us put a capacitor in parallel with the load. This one. So this is now your capacitor. Your capacitor will take a leading current, right? Your capacitor is a leading power factor. Leading power factor. So this is your IC. Okay? Can you follow? Okay. Your IC, your IL is on the downward direction because it is lagging. If that is a leading, it is on the upward direction. Okay? So, let's say this is your current IC. That one. That is 90 degree for purely capacitive load. I will project this size. Let's say this is 5 inches. I will project this size. Listen, I will project this size here. Let's say somewhere down the road here. This is your IC, right? Now, this is your total current from the origin going to this point. This is your IT. And your IT here is this. Your IT means total. Your total current, of course, by Kirchhoff's current law here, that your total current is equal to what? Your load current plus your IC, right? Now, let us assume values. Let us assume. Let's say your IL is 100 ampere. Okay? So, there is a negative angle here. Let's say we have a negative 40 degrees. Plus. So, we have an IC here. Assuming 20 ampere. Any value, huh? So, assumption, this 20 is on, I only assume this. So, this is plus 90. Will you add that? What is the answer? Mode 2 plus. Mode 2. Calculator nyo mode 2, then 100, 6 negative 40 plus 20, angle 90 degrees. What is your total current? Give me the value. Okay, hello po. Bale, ano na lang po, stop na po muna natin to, no? Anyway, meron din po tayong video po nito sa ating YouTube channel, no? Pwede nyo pong i-download, ano? Although hindi po yung eksaktong-eksakto na katulad po nung ating video na napanood, no? But the principles, no? So, nandun pa rin po yung mga principles na mahalaga. Kaya pwede nyo pong i-download yan sa ating YouTube channel, The Reggie Marina YouTube channel, mga kawerpa. No? Hanggang dito na lamang po tayo. So, extended na po tayo eh. So, salamat po sa inyong lahat. So, bali next Tuesday po, ulitin namin, 2:30 po tayo magsisimula hanggang 5 PM lang po. No? Starting next Tuesday po. That will be March 8 po. Okay? Sige, salamat po sa inyong lahat. Thanks be to God. Ingat po tayo.